Hello, ladies and gentlemen. Good morning, Starbase. Welcome back to the second launch of a super heavy launch vehicle within the last 24 hours. It's a beautiful day on the beaches of Texas, and we're preparing to see the first launch of a new Starship configuration, the Block 2. Well, I'm your host today, one of your hosts. My name is Paragy. With me are my two friends, Quantify VTOL, if you'd like to say hello. And
Yeah.
we will be joined in a second by our other host, Jacob Cluting, also known as Jacob Connect on Twitter.
Yes, hello. I go
Hello.
by Quantify. I'm studying aerospace engineering and I'm specializing in drone engineering. Been following Starship for a while, so I'm just here to chat along.
My name is Jacob. I am currently in a high school looking forward to aerospace engineering at York in Canada, and I am happy to be here.
Well, with an absolutely star-studded cast today, we are coming in and looking at Starship Flight 7, which is the first of a new host of upgrades for the Starship system. As I mentioned previously, Starship Block 2, one of the biggest upgrades that we've seen to the ship in a while. We can see quite a few things on the ship, just evidently just by looking at the thing. Um, we can see that the flaps have moved from previously. We can see that they've added catch points. We can see that the ship is longer. Um, they now have doubled the number of raceways on the ship, moving from one to two. There is additional nose cone tiling and stringers. And we can see on the booster, opposed to other flights, there is a ring of stringers right below the common dome, added as reinforcements. Um, Mr. Quantify, would you like to cover the flaps for us, please?
Yes, good morning. Well, not good morning, but nearly. Well, you can see from that view actually quite clearly, the forward flaps have been moved to a far more leeward position. One of the great things about having flaps in a vehicle like this is you can put cameras basically everywhere. So SpaceX have had access to some of the best re-entry footage in history, and that's allowed them to visualize exactly where the plasma is actually flowing. From that, they've learned that they can move the flaps quite a bit further back, and alongside that, move some tiling rather than far back along the sides of a flap, more forward on the nose. It's allowed for a weight reduction, it's allowed for hopefully uh, better re entry dynamics. More of the heating will be concentrated on the actual body rather than on the flap hinges themselves, and they should still provide enough control to get through all the stages of flight. In last flights, we saw a lot of issues with the flanges around the forward flaps. This will hopefully mitigate them. If not, we might see a little bit of burn through, but that's to be seen today.
Should also note that burn through issues were significantly mitigated on the last flight, Flight 6, which, if you've not seen our coverage of, you should probably see after this little stream we have today. Right, moving on to the next point on Ship 33 that we can see as upgrades. Ship 33 has uh, two large jutting catch points. They are load points that are basically allowing the ship to take the load of catching. These are purely structural today. These are not the full catch points that will be used to actually catch the ship, which is expected to happen around the next flight, Flight 8. However, these ships will be identical in viewing and how we generally will see them on all future ships. These, if you are able to see some external imagery, they look very similar to the catch points on the booster. They are significantly thicker, however, and are designed to take the heat of reentry rather than the boosters, which are purely structural and don't need any extra reinforcement. Um, we have seen some tiling on the top of the catch points. These are likely just to continue to reduce heating. These will continue to be used for the foreseeable future and will be the recovery mechanism for all starships. All right. Well, why not deployable pins? This has been an interesting point of contention among the spaceflight community, and we've generally come to the consensus that deployable pins would have issues with both reliability and the long-term scale of thousands of flights. They might be extremely complex and annoying to manufacture, and they might not be able to hold the full weight of the ship on landing, which may be over 200 tons once header tank fuel is accounted for. These all combine to make the very simple catch pin that we see, that is a simple slab of metal, to be the best possible option. Jacob, would you like to take over for the next point on why the ship is significantly longer? Well, not significantly, it's only a ring.
Sure. They're added fuel to add more payload capability for the ship. And that's in order to make sure that SpaceX can hit payload targets needed for Starlink and HLS, which are heavier. And it slightly changes the fuel mixture on Starship to account for later Raptor 3 engines.
Yes, thank you. Overall, it should bring Starship's payload up into the range of from 100 to 150 tons. We're not exactly sure on how much. SpaceX is somewhat vague on their own website about how much this will change by. We might see another change is the shortening of the payload bay from the previous generation of ship. I believe that around 2 or 3 rings have been removed from the payload section of the ship and thus have been added to the fuel section, along with an additional ring entirely to the length of the ship. With all of these changes together, again, as Jacob stated, these will help bring up payload counts for Starlink, HLS, making sure that Starship is the best vehicle it can be for the time being and moving forward. Along with
Elon
this,
Musk seems to think that Starship has a long way to go before we hit the limit of the rocket equation, so it could get an awful lot longer.
very much agreed. Mr. Quantify, would you like to take over the doubled raceway?
Doubled raceway, sure. So, previously we saw a single raceway design. They've now split that into 2, so now we have plumbing pipes for electrical and just regular plumbing equipment, which are running down 2 sides of the ship. That gives far more redundancy. We've now hopefully got 2 separate control channels for control signals. It's overall safer. That does also make refueling and docking quite a lot easier. As we've seen, there is interest in placing a docking port on the top of Starship. That just makes a little bit of wiggle room for it. There's also quite a lot of talk about refueling at the moment, since future ships, which will almost certainly be produced soon, are probably going to feature hot gas thrusters. These aren't present on Ship 33, but making a bit of extra room along some of the axes of the ship will help to accommodate them.
Thank you very much. We can see on the top of Ship 33 that there's a significant amount of additional nose cone tiling. This tiling is fairly obvious once you've seen the previous generation of this generation of ship. Quite a few more rings of tiles covering much more of the gap between the flaps, which you can see because the flaps have moved up. This is likely to help with a couple things such as heating during re-entry. We've seen that tip of the nose cone is exposed to a significant amount of heating rather than just any other part of the ship. So additional heating mitigation is important here, along with making sure that the header tanks are not exposed to too much heat during the of re-entry, and the header tanks, of course, contain the cryogenic fuel that Starship needs. Starship is, of course, landing propulsively and thus requires the cryogenic methane and oxygen to remain at temperatures that can be used in the Raptor engines for landing.
For those of you who missed it, the liftoff time for Starship has been moved to 4:37 p.m. Central Time, just slightly forward.
Alrighty. So that means that we are slightly more than 2 hours out. So
It means we have to blabber a bit more. We have to deal with us for longer.
Well, you know, what's time when you're having fun? Okay,
Tank watching.
here we go. Right, that's true. That is the philosophy this whole phenomenon that we so love is based on. All right. Well, the nose, going back to it, it does provide a little bit of a new look for the ship. However, there's more than just the look. And speaking of a new look, the stringers, the bands of stringers that can be seen around the barrels of the ship. Now, those unfamiliar with the sport of Texas tank watching may be unfamiliar with the fact that the ship does, in fact, have these barrels with stringers on them. Previously, they were covered up by these phenomenal pieces of technology called weld doublers, which are really just plate of steel added around to an existing band of stringers to increase the thickness and increase the ability of load that an area is able to tolerate. These stringers are not new. They've been there the whole time, but now with a ship that has been significantly lightened, these weld doublers are able to be just stringers now. And because they're able to be just stringers, we now see them externally rather than just being covered up. Speaking of additional stringers, on the new Booster 14 flying for the first time on today's flight, we see a band of stringers around the dome. Those have always been there, but noticeable now to a wider group of all of us all who love to watch these things is the new band of stringers that is just below. These are likely to deal with the fact that, as my co-hosts have mentioned, the Starship for this flight will be significantly longer and will be carrying an increased propellant load, which means an increased weight load for the booster. And because it'll be an increased weight load for the booster, it will need to be able to handle the increased squishing strength of that ship when it starts firing all 33 Raptor engines.
That is a brilliant engineering term, Peregrine.
Thank you, thank you. As you can tell, they pay me for my technical excellence.
Squish factor must not be underestimated.
Clearly. We, of
That
course...
would be a bit embarrassing if it just crumpled, wouldn't it?
Of course. But, you know, hasn't done that yet. If we thought it was going to crumble, it would have most likely done that during Flight 1 when it tumbled end over end. But, of course, we're not expecting to see any tumblings of end over end today. That would be quite embarrassing indeed. Alright. Moving on, we are expecting to see quite a few events during this flight. So, first of all, the reprisal of the catch. Flight 6, of course, experienced a very embarrassing offshore divert, much to the chagrin of every single photographer in the area, who, of course, was betting on Booster 13, the unlucky soul that it was, being caught. But today, Booster 14, next booster up, we are expecting to see it conduct a catch. Potentially, we may see a reflight of this booster in the future. We already know that a Raptor from Booster 12 is being reflown, although the exact serial number is currently unknown, despite some speculation on Twitter. Starlink simulators will be deployed. They are to 10, and they may include cameras on board. This is, however, speculative once again, and we are waiting to see what will happen with those. However, this will include a complete flight, a repeat of the test from Flight 3, in addition to full deployment. The payload bay door will be opened in space, and we will be able to see those Starlink simulators being shot out one by one. All right. Mr. Quantify, again, would you like to take over the remaining two objectives for this flight?
Yeah, so we're seeing, hopefully, another Raptor relight. So the purpose of a Raptor relight is essentially to certify the vehicle for on-orbit operations. Obviously, if it gets up into orbit, it needs to be able to come back down again. Flight 6, that worked well. It was a very short, low impulse burn, worked pretty much perfectly. Hopefully repeating that again with Flight 7. And then the biggest thing, really, is that we're seeing what could be a potentially dynamic entry. As we've mentioned, this Starship has an awful lot of different cooling systems being tested, a completely different configuration of tiles on the nose cone. There might be different plasma flows around the leeward flaps which are to be observed. Could be potentially unexpected heating in certain areas. So it'll be very interesting to watch in close detail. I'm sure it'll give us lots of good camera views. We've also, in particular, that really interesting tile, the actively cooled tile, which hopefully we'll be able to see in a camera view.
Hopefully. Well, of course, active cooling is the process in which a tile will be cooled with some kind of fluid, some kind of chilled fluid from the vehicle. Likely in Starship's case, it will either be liquid oxygen or liquid methane. It is much more likely to be liquid methane in Starship's case. It will be chilled. I believe that we have the exact location of the tile. However, SpaceX, excuse me, has confirmed that it and several other demonstrators will be flying on board this test. These demonstrators range from purely metallic tiles to other things, again, such as actively cooled tiles we mentioned, to slight reformations of the existing mix of TPS. This will be a very, very dynamic flight indeed, and we're looking forward to showcasing all of it. Now, one other thing that you might expect to see during this flight may be some issues with Ship 33. Now, like the previous flight of Ship 31, a good amount of TS tiles have been stripped from it, and these tiles are in sensitive locations to the airflow. Now, because they're in sensitive locations, they likely will cause some heating issues. Now, unlike Ship 31 and like its older brother, Ship 30 from Flight 5, we can clearly see that new ablative heat shield tiles can be seen all over the ship. These are where the small divots in the heat shield are that you might be able to notice. These little divots are removal of the original thick ceramic tile, and beneath it are these ablative tiles. These are used a measure of glue and pins, unlike the older ships, which is almost an exclusive mixture of either pinned tiles or glued tiles one way or another. The main sections of the body are made up of multiple kinds of these attachment methods now, most likely building off of experience from all three previous flights.
There's a lot of tile cooling terms here. It's probably been tossed at you. So for those of you who aren't aware, actively cooling a tile involves, at least in what we think SpaceX is doing, is pumping a cooled liquid or fluid through tiny holes in that tile and essentially allowing them to transpire out of the tile, wicking away heat. And then we've got ablative tiles. Ablative tiles essentially allow the material to ablate away, burn away with heat. It means it is a consumable tile, but it's a fantastic redundancy to have. It's how most heat shields have worked in the past, especially on crew capsules, and it's one that SpaceX would preferably like not to use because it requires quite heavy servicing after every flight, but it's there as a redundancy. Current tiles SpaceX use are essentially just ceramic tiles, which just absorb and wick away heat normally, very similar to the space shuttle tiles.
Yes.
Of course, there's a lot more of them than on the space shuttle, so it's a massive weight issue that still needs to be figured out.
Of course, which is why some of the active cooling demonstrators are flying today. The ablative heat shield serves to go underneath the original heat shield in case one of these tiles falls off. It's designed to guarantee survivability for the ship. Of course, the idea is to never have to use any of these in any kind of scenario. However, for these original missions in which they aren't getting 100% reliability and are still trying to figure it all out, an ablative heat shield underneath will keep things moving and help keep things alive, very importantly. Secondly, of course, we can see that these ablatives, because they're designed to be a redundancy, are very helpful for future crewed missions in which reliability is going to be a very, very important factor for Starship. Unlike previous designs, there will be a second layer of redundancy, which again will help with crew. This will help with Starship's future Mars ambitions and getting things completely ready on the regulatory side, and most critically, safe for humans. SpaceX is, of course, they can seem quite reckless on the surface. However, time and time again, we have seen that they do have a commitment to public safety. For example, during last flight's public booster offshore divert, in which, again, it would have been somewhat of a bad idea to allow that booster to keep going, and they diverted it into the water.
At least as a reassurance, that divert was not due to a vehicle side issue, but rather a ground side issue. SpaceX lost communications with the launch tower, or at least one of their communications channels. One of their commit criteria for a catch is that they want to have all redundancies available, so if they lose some systems, but not all, that's still an abort.
Exactly.
Hopefully that doesn't happen again today, but some are theorizing that might have been due to the plume on launch.
Yes. Hopefully, again, no offshore divert today. All of the wires should be downed. All the double checks should be checked. Everything should be good and in its proper place. They've had about 2 months since the last flight to work on this flight, rather than the absolutely blistering 1 month that came with the flight last time. Some of that delay was because of wanting to recertify the Block 2 ship, get that static fired, 100% assured, and recently, throughout this entire last week, it has been almost purely from the weather.
The weather looks a bit better today.
Yesterday was extremely overcast, quite a bit of stuff going on. But we are much better today. I think the visibility today is around, the cloud layers are around like 1% today, something that's quite absurdly good rather than what we had previously. As we mentioned during the original parts of the introduction, there is, this is, of course, the second launch coming from today. The first launch of a Super Heavy launch vehicle that occurred today was New Glenn, which was carried out at 1 a.m. this morning and was quite an entertaining flight. So that launched. We should be able to eventually bring you some nice photography from our photographers down in Florida. And pretty soon, we will both be able to see both of these incredible launch vehicles working in tandem. An example for the Artemis program and the HLS program coming in the future. Quantify, would you like to take that?
Sorry, one more time, I've been sorting my microphone.
Oh, excellent, don't worry. A little bit about the
Multitasking.
way that New Glenn and Starship are expected to work together under the Artemis program, if you will.
Oh, well, yeah, the Artemis program is pretty exciting. It's one of the first massive collaborations on a giant aerospace project that we've seen in a long time. Starship and New Glenn hopefully fill pretty similar roles. Starship's obviously being considered for the HLS program, which will allow it to become a lunar lander, so it's been quite multi-role there. But New Glenn's still going to be an incredibly valuable heavy lift vehicle.
Agreed. So one common element between New Glenn and Starship is both of their use of refueling. New Glenn is expected to take somewhere between 4 to 8 flights to refuel their home-built cislunar transporter spacecraft, which will be designed to shuttle liquid hydrogen and liquid oxygen between the orbit of the Earth and near rectilinear halo orbit, or even lower orbits as Blue Origin sees fit. Now, these flights will be carried out on the order of NASA or privately. Blue Origin has expressed interest in doing private missions with their human-rated designs, and so has SpaceX. SpaceX, on the other hand, their use of refueling is a bit more heavy-handed. Uh, they are taking up to 16 flights. In addition, I believe, no, sorry, not in addition. The HLS launch and then a depot launch and then the 14 or 15 tankers that will come after. These will serve to refuel the ship. The ship will first be refueled in low Earth orbit, and then after that, it will be boosted up to an almost geostationary transfer orbit, where it will meet again with a depot ship, refuel, and be sent off land human beings on the moon. These both are the different approaches being used by both of these excellent, large, super heavy launch vehicles for the future of human exploration, but they're quite similar in their own ways.
Oh, I've had a lot of people complain that they don't really need to be two separate super heavy launch providers for one single mission, and some complain about the increased budget. But NASA themselves have said that they really just want more redundancy, more competition, and a regular cadence of launches and landings. As the same reason why Blue Origin, actually fairly recently in 2023, in May, I think, was selected to develop their own landers, which they'll hopefully be launching on New Glenn as well. So New Glenn's going to get some work done.
Of course. Starship and New Glenn, of course, are expected to serve as almost competitors to each other in this new space age. We know quite a bit about why competition is important. It helps drive down prices, it helps companies keep innovating, and it means, most of all, for all of us space fans, that we get to see more launches, which, of course, is the most crucial part. Now, a little bit more about Starship and New Glenn's landing efforts on the moon. New Glenn, supposedly later this year, is expected to deliver a smaller prototype version of their Blue Moon lunar lander, Blue Moon Mark 1, to the lunar surface. It will not be capable of carrying human crews, however, it will be carrying test equipment for the much larger Blue Moon Mark 2 lander. This lander is planned to be launched on a New Glenn, sent to near rectilinear orbit on its own propulsion, and then rendezvoused with and docked to, and then transported by the cislunar transporter to either dock with Orion or another capsule in near rectilinear halo orbit or any other orbit. Given that, of course, the upcoming changes in administration, nothing is certain, but what is certain is that all of these rockets will play a role in.
You said that New Glenn and Starship are meant to compete. Um, if I remember correctly, New Glenn's payload volume is around 16,000 cubic feet, whereas Starship's is about 35,000 cubic feet. How can they compete when one seems to have a clear advantage over the other, at least in payload volume?
Well, the things with payload volumes is that it doesn't just exactly matter how much volume you have, it also matters on the specifics of that volume. For example, if you just had a flat pancake, that wouldn't really be useful to launch that many satellites. New Glenn and Starship, their main basis on competitorship, is based on how large they are, and how we define large usually in the rocketry world is how wide they are. Starship is around 9 meters wide, and New Glenn is around 7 meters wide. And because of the individual differences in the payload envelopes, not all of Starship's widened space is usable to the exact extent that New Glenn's is. So what ends up happening is that you will have two launch vehicles, which will have both remarkably tall and remarkably wide fairing bays that will be able to launch heavy payloads and smaller payloads, and both of them will be using the most recent technology to be reusable and cost efficient. And so, what will happen is that both will continue to compete with each other on their own merits, and then eventually we will just see more and more launches from both because they're both able to serve the same amount of customers. Now, some might say Starship is able to launch 150 tons, whereas New Glenn is only able to launch around 45. Well, first of all, that's of course counting whatever upgrades New Glenn has in store, but second of all, we don't have the same amount of truly huge payloads in the market yet. I believe that some of the largest payloads we've lofted so far are only around 20 tons, 30 tons. I'm not sure, I don't have specifics on my head, but I don't think any module ever docked to the International Space Station was more than around 20 to 30 tons, if that, given the fact that the space shuttle, which had a very limited payload in that sense, was launching them. Because of that, for the very foreseeable future, these two will be duking it out over the larger market. And frankly, at this point, it could be anyone's game.
Just before we carry on rambling about this, I will say someone's just gifted 5 memberships in YouTube, so thanks very much for that.
That's incredible. Thank you very much. Very, very much.
Thank you.
Thank you.
Continuing off of that, I've just looked it up. The entire GEM, Japanese Experiment Module, was 24 tons, 24,000 kilograms, which was, the entire thing was delivered by the space shuttle in multiple flights. That's the largest payload I could find that isn't Skylab.
Yeah, to be honest, it's a bit of a tough question, because if Starship works as well as SpaceX actually want it to, there's a very real chance nothing can compete. But it seems to me that Blue are going for the ULA strategy that's kind of dying out now, which is offering reliability in simple vehicles. Obviously, Starship is much more complicated. There's a lot more that can go wrong, there's a lot more mission objectives, and I imagine SpaceX isn't quite as happy to expend Starship vehicles as ULA is. Obviously, Blue Origin will hopefully provide a really nice stepping stone as we transition into the big Starship kind of market. And yeah, as previously said, there just aren't enough big payloads to fully use Starship's volume yet. We've already seen companies being set up that exist solely to create big payloads fitting in Starship's payload bay, and even those are struggling massively because SpaceX keeps changing the bay size. So it's going to be a while before SpaceX properly corners the market, if they do at all. And to be honest, if they do, and if Starship works as well as they say it will, which I'm not sure, but we'll see, it's likely competition is going to move into low Earth orbit rather than the launch market.
Agreed. Agreed. As said before, because SpaceX has changed the base size, this does provide a unique opportunity to New Glenn, because ever since I believe the Payload Users Guide was unveiled in 2017-2018 for New Glenn, it has been very, very consistent. The fairing length has stayed identical, the diameter has stayed very similar. I don't think that there are many changes coming to New Glenn in that sort of way. We will be watching, we will be seeing how it changes. Of course, we don't expect Starship to be artificially limited forever, of course, if they can simply pull off a stretch of this caliber, and then a later stretch to version 3 of Starship with relative ease. I don't think it's within the realm of capability. Of course, SpaceX will be kneecapped. What we will be seeing for the near future is good competition between the two large launch providers, which will be very, very helpful and optimal. On that note, the number 3 has come up multiple times within the Starship lore as of late. Raptor 3 and Starship version 3 are, of course, two very, I would say, divisive hot topics. Well, perhaps version 3 much more than Raptor 3 at that. But when we see these two much more advanced forms, there's been a lot of discussion around those. Quantify, would you like to take over some speculation about the current Raptor 3 design?
I'll be honest with you, man. Propulsion is not my thing, but my professional engineering opinion on Raptor 3 is that it's black magic and a little bit scary. I mean, I can't remember the exact figures, the chamber pressure that Elon Musk was saying they're aiming for. Isn't it something absurd?
I believe it's around 350 bar, I think. It might be 300,
Yeah, that's
350,
absurd.
I'm not sure. Yes, whatever it is, it's completely right. It is very much black magic in a box. I believe I'm not sure on the current thrust output. I believe it's somewhere around,
380, I think.
yes, exactly. Quite, quite extreme. Uh, Of course, Raptor is the full flow staged combustion engine that powers Starship. 280 tons of thrust is the goal, which is up, I believe,
Pretty sure
I believe
300 is
around
actually the stated
200,
goal.
235 tons of thrust from, yeah, 230 tons of thrust. Overall, that will mean from the very first Raptors that powered the Starship SN hops, for those of us who have been around long enough to remember them, that we will be able to see an over 100 ton force increase per engine per flight. This will mean now that with Raptor 3, two Raptor 3s together will be able to output more additional thrust than the previous three engines that an SN prototype would have altogether. It's an incredible innovation, and it's designed to power one of the more controversial upgrades to the Starship launch system, uh, Block 3 or version 3, which ever you prefer at the time.
I will say with Raptor 3, I think it's a really interesting change in SpaceX's design philosophy that they're starting to weld, pipes and electronics into the actual engine itself, makes servicing it nigh on impossible, and it changes the philosophy to one of servicing to one of total replacement. So it's pretty evident that SpaceX intends to mass produce these engines at a pretty crazy rate and just throw away the ones that don't work anymore, which is very interesting and might prove to serve them well if they end up sending a lot of these vehicles to Mars.
Agreed. Agreed. Raptor 3 again also has a pretty significant increase in efficiency ISP over the Raptor 2. I believe it goes somewhere from 340 something's 345 seconds or abouts for the optimized sea level variant in vacuum to around 350 seconds of efficiency for the sea level optimized Raptor, and somewhere from around 370 seconds for Raptor 2 to around 380 seconds for Raptor 3 for their both respective vacuum optimized versions. It's a giant leap in both efficiency and thrust, and an absolute triumph by the SpaceX materials and engineering team.
It's also cool that Raptor 3 is one of SpaceX's stated goals for developing it is to eventually get rid of the projective engine shroud concepts entirely and have the engine shroud its own electronics and its own plumbing, which is really cool.
Agreed, agreed. One of the biggest reasons that SpaceX wants to get rid of these shields and all of the external engine plumbing is because of a phenomenon that we've seen on both Flight 5 and 6, which is the plasma that builds itself up in the engine bay of the Starship booster, Super Heavy. When it comes back, you can see that there's a large amount of trapped plasma that comes and circles around the interior of the what we've christened, I believe, our very own Mr. Space Engineer. You can follow him at MCRS987 on Twitter. Coined the thrust bowl, which is the current structure that the current engine layout is in, where it where it kind of cups the thrust and the thrust rings cup in a large amount of plasma and allow it to build up over time, which, of course, not very helpful when you're trying to reuse the booster and stand up to so much heat.
Those of you who are watching without video, just to let you know, we're now 1 hour, 27 minutes and 30 seconds away from launch, so still got a bit of a way to go. Still appears to be go, though. SpaceX haven't cancelled it yet, hopefully.
Going back to Raptor mass production, which was discussed, do you think there's any chance that, like Blue Origin, SpaceX will license out these Raptor engines or sell them for other companies to use. Thinking like space tugs. Are there any practical uses for that kind of technology with other companies, or do you think they're just going to keep it to themselves, kind of thing?
I think there are definitely practical uses, but I think SpaceX would rather go bankrupt than leak that secret. I think Raptor
It's
3 is one of the
probably true.
greatest innovations in rocketry, probably in history, and they'd rather keep that locked down. What they probably will do, and I think they're already doing with some things, is providing on-orbit electronics, stuff like star trackers, maybe small ion engines. Those are helpful, and that provides a little bit of extra revenue, and it's mostly technology that's already out there. But Raptor, I think Raptor's staying as a trade secret.
Very
Makes
much
sense.
agreed. Very much agreed. One of the other things about Raptor that makes it slightly impractical for other on-orbit uses is the fact that it's such a high-thrust engine. Now, being a high-thrust engine is very, very nice when you're your own large, bulky vehicle can handle and be built to design around all that thrust. However, in orbit, thrust isn't really as important as efficiency. And the thing is, well, 380 seconds is an absolutely phenomenal ISP, and I don't think many other competitors will be able to match it. The fact remains that you can, in fact, go higher, and with the lower thrust of potential other offerings, they will be infinitely more appealing for other kinds of building. For example, Impulse Space has their very Helios space tug, which is designed to support multiple payloads and boost them up to geostationary orbits after deployment by any launch vehicle. I believe that Helios is a very launcher agnostic tug, and it has an engine called Deneb, which is a much lower thrust engine, which means that it will, of course, be much easier for vehicles to be constructed around. It'll need less stiffening and supporting, and therefore less dry mass, making for a much more efficient stage. It also has a much higher ISP than the Raptor 3 vacuum, around 390 seconds, which I believe is touching the very, very upper practical limit of what you can do with methane and liquid oxygen propellants. It's very similar to Raptor, however, it's not built in the same full flow staged combustion stage. Instead, it uses an oxygen rich staged combustion cycle. This does not have the same fuel rich and oxygen rich preburners that Raptor has. It only has the oxygen rich preburner. Jacob, would you like to explain very briefly what the basic idea of a preburner is?
Sure. If I remember correctly, not as technically minded as you two, but a pre-burner is used to, well, pre-burn the gas, and this expands the gas, and then it could be used for utilities such as turbo pump spin up, if I'm getting that correct, which can help pump the fuel faster into the engine, make it combust better.
Good. Yeah. Here, I can take over. The idea of a pre-burner is exactly what Jacob said, to burn an existing amount of propellant in a given cycle. So some of these will have a higher mixture ratio of fuel to oxidizer, some will have a lower mixture of fuel to oxidizer. What a preburner is able to do is spin up the turbo pumps to the existing speed, to the set speed rather, to enable Starship to and its Raptor engines to power up and exactly produce thrust. Turbo pumps pump fuel into the main combustion chamber of the Raptor engine, which is where, of course, well, somewhat implied by the name, the main combustion takes place. Now, preburners, the thing about them is that they are somewhat inefficient by nature. They are burning an off nominal mixture intentionally to either make the conditioning easier for the turbopump or harder for the turbopump. Both they serve in their own ways to limit or condition what's going on in the turbopump. Now, oxygen-rich and fuel-rich are very different. A fuel-rich mixture will be much more efficient and cooler, while an oxygen-rich mixture will be by nature much more hot and ready to combust. This ends up with you needing significant amounts of alloys, like the SpaceX team has designed for Raptor 3, their own custom proprietary in-house alloys to support the extreme temperatures that are going inside of Raptor. However, I'm sure that many of you have heard the good old full flow staged combustion lecture, but of course, there's no harm in hearing it again. The full flow stage combustion cycle allows you to take both a oxygen-rich and fuel-rich preburner, allowing you to take both of those very inefficient mixtures with hot gaseous versions of both unburned fuel and unburned oxygen and combine them in the single main combustion chamber to get as much use out of all of your propellant as possible. This means, of course, that it enables Raptor to boost up to those incredible ISPs that we've seen, and, of course, have come to know and love when these rockets take off.
I just want to quickly butt in. You've probably heard that figure ISP been shouted a fair bit. For those of you who don't know exactly what it means, it's basically just a measure of how efficiently a rocket generates force per unit of fuel. Higher ISP equals less fuel for more delta V. The limit really around Methalox is around 380 to 390. It's a theoretical kind of limit, if I remember correctly, and Raptor 3 is very rapidly approaching that. Most RP4 and liquid oxygen engines are around the 300 second mark, so SpaceX is already achieving really great efficiency. Why it's in seconds is because of some funny unit messery.
Of course, the basic idea, again, as he said, of ISP is fuel efficiency. Now, another thing that has come in with Raptor that you can somewhat see just by looking at the thing is the massive amounts of reduction in dry mass. The other part of the rocket equation, of course, as it's known, is not just the efficiency of your engine, but also what is known as the mass fraction. How much dry mass you have, how much fuel you have, and the ratio that will help determine where you can get to in the solar system. Now, Raptor 3, while it's starting to hit the theoretical limits of combustion in its own main combustion chamber, it's also starting to rapidly approach the limit of how light they can possibly get the engine. I believe that it moved down from somewhere around 5 tons of on-board vehicle support on Super Heavy for the version 1 of Raptor down to around 3 tons on Raptor 2, the current version that's flying on this ship, and it's shifting down to somewhere around 1.3 tons total for Raptor 3. Now, this will keep getting the thrust-to-weight ratio higher and higher, allowing SpaceX and Starship to get more and more capable. And eventually, of course, this will, again, lead to higher payloads, and, of course, version 3 of the ship. Now, version 3 is something I've been alluding to a little bit throughout the stream, and I think that version 3 is clearly one of the most controversial changes to the Starship system. So, Quantify, would you like to, if you're familiar with it, would you like to explain the concept of the version ship and booster?
Fortunately, I've been away from the planet Earth for about 6 months, so I think I may not be suited for this, Verity.
Well, in that case, it will fall to me. As I stated previously, the booster and ship version 2, as you know them, are coming. Of course, this ship is the first flight of the version 2 ship, which features a bunch of dry mass improvements and some improvements notably in fuel capacity. Now, on version 3, the idea of fuel capacity is going to be taken to what we originally believed to be an absolutely ludicrous extreme. When SpaceX first unveiled the documents for version 2 and version 3 of the ship, we saw that version 3 would be almost as long as a super heavy booster, and that was deeply shocking and terrifying to many of us.
Oh,
However,
I remember this now. Comically large ship.
Yes. However, as we've learned from Elon Musk's tweets as of late, that is no longer the case. The ship and booster will still, of course, improve in length, but the ship and the booster will not be, in fact, that egregious hulking monster that we've seen. The ship is likely only to extend around 10 meters more, nowhere near as much. Sorry, no. The entire ship and booster are likely only to stretch around 10 meters more, which is a very good news to all of us who at least love looking at this beast rather than simply gazing in horror. It is primarily designed to bring the payload capacity of Starship up to 200 tons from the existing 150 tons that is on the ship currently. Now, um, as Elon Musk stated, it's only about 10-meter stretch total of the total vehicle, I believe, and this should allow plenty of space for either the booster or the ship to grow. And in that space where the booster and the ship will grow, we will see another increase, which is the increase in the number of engines. Now, SpaceX has mentioned the number of engines increasing many, many times. However, they've never truly implemented it, and we see this implementation on the Block 3 ship. It will go from having 3 Raptor engines, Raptor sea level engines, and 3 Raptor vacuum engines, to having 3 Raptor sea level engines and 6 Raptor vacuum engines. This will be to boost the overall performance of the ship, make it more efficient, because as we mentioned, if you might go back to that, the vacuum engines are much more efficient in vacuum than the sea level engines, somewhat by their nature. And, well, just adding more vacuum engines will boost the total thrust, keeping the thrust to weight ratio sane for the ship, and allowing for continued performance even with an extended ship. Now, we are expecting to not just see a lengthened ship. This is also expected to come with a depot. A depot is the Starship method of fuel storage, and we've seen plenty of visuals from SpaceX alluding to it as of late. The depot is supposed to be somewhere around the original length of V3 and have propellant tanks extending all the way into the nose, as opposed to the current ship, which only has propellant tanks in the current well in the current area of the fuel tank sans the nose cone. This will carry, I believe, around 3,200 pounds. I'm sorry, not pounds, tons of propellant. If it carried only 3,200 pounds,
I could carry
HLS
more
would
than that
not
in
be
the gym
making
on a
it to
leg
the moon. Yes, no, Starship would not be making it to the moon if it was only 3,200 pounds.
We make it to 20 meters though.
Yeah, yeah.
I will, by the
Well,
way, say we are watching the chat, so if you do have any questions, don't be shy to ask it. We're going
yes,
to be here for a long time, and there isn't that much to talk about, so please do chip in.
yes, please. I may sound like I have it together, but in fact, I do not have much to talk about, and am rather coming up with stuff on the fly.
So I'm getting
So,
pretty chilly in my room. I think the air conditioning's a bit too cold.
In a lot of the media that I've seen for the propellant depot, correct me if I'm wrong, but it doesn't appear to have any heat shield tiles or any kind of control surfaces. So is this version of Starship meant to stay in orbit and then just be disposed of when you're done with it? Or
Yes.
yep.
I mean, at its core, Starship is just a long stainless steel tube, so if you strip all of the expensive bits from it, it is just a stainless steel tube with fuel tanks and engines. So it's really cheap to just toss them into space and leave them there and deal with them when you need to. And I think
Agreed.
it's a really interesting ecosystem idea.
However, that is in fact not just purely what the depot for HLS will be. The depot from HLS, as we've seen outlined in several Artemis documents, will be its own fully fledged out vehicle. It will not be as expensive, of course, as a regular ship. However, it will come with its own suite of features, which will include specialized thermal protection tiles, which are currently undergoing testing at NASA Marshall. Now, when I say thermal protection tiles, like the unlike the current thermal tiles that are designed to deal with the heat of reentry, these thermal tiles are very special in that they are designed only to deal and reflect the heat of the sun. Of course, when we're talking about cryogenic payloads, like Starship uses here, keeping them cool, very cool, is very important. And if you're keeping it in low Earth orbit, there happens to be a bright yellow ball of atomic fire that is very, very determined to keep you from keeping your propellants cool. Now, there are some active methods to deal with this, like radiators, which the version 3 depot is believed to have, but most critically, it will also have these passive mitigation measures through things like these tiles, through other forms of active cooling. These will serve to make sure that the fuel is kept all nice and cool and ready for its eventual use.
Just a couple things quickly. If you take a look at the stream, we've got a really nice shot of some tower venting. So SpaceX does appear to be go for propellant load.
Quite excellent.
That's
That means
beautiful.
we haven't wasted our time.
That means I can sleep with a smile on my face, maybe.
So is the depot doesn't have any actual reentry thermal protection. So does that mean that each depot will be expended after use?
Very likely, yes. Each depot will likely be expended after its use. However, what its use is could vary dramatically based on what mission it's designed to serve. For example, the propellant depot for Artemis 3 is likely to be expended because it will only serve for the 14, 15 or so refuelings, and not much else will be done with it. However, for things like future Mars missions, it would make sense to simply just have a continuous fleet of depots that just come up, get refueled by ships, and just continue to cycle out propellants as they cycle through Mars to Earth, to all the places they need to be. The end of the depot's life will be determined most likely based on either when it is no longer needed, which could be quite a long time from mission to mission, and like Mars, Moon, all those kinds of things. Could be quite a while, but in the upcoming years, I would expect immediately for it to be limited. Thank you, Miss Olivia Staley, for the 199 super chat. Thank you so much. We appreciate it. Keeping funding for Interstellar Gateway is awesome because we're able to keep bringing you these views, everything we can. Thank you guys so much for your support.
Yeah, at the moment the whole team is being paid about 20 cents a year for their efforts. So anything helps.
We'd like to, yeah, to make that abundantly clear. That is in fact a joke. Joey Leal is a very nice gentleman who keeps us all very
a wonderful
well paid.
fellow.
Yes.
Lines the coffers excellently.
As they say, do not bite the hand that feeds. Okay, well, as we're continuing into just breaking kayfabe a bit. Yes, no, they get we get. Do not worry about if we are paid or not. Okay.
I will also say it's pretty interesting to see so many companies looking to the future of kind of a post-Starship world, and there is definitely some use in having so much stainless steel in orbit. So I imagine some of them will probably be used for scrap or for some kind of small space stations or outposts.
Speaking of scrap,
there's no need to get rid of everything when on-orbit scrapping becomes a thing.
yes. Speaking of scrap, and reusing existing starships, I'm a bit unfamiliar. However, I know that SpaceX did propose a space station using in their commercial LEO destinations program, using Starship and eventually using the large payload sections as a kind of wet lab of sorts. A wet lab is when you take the existing tanks of a space station, if you launch it on a large launch vehicle, for example, and you convert them to a workable laboratory in space. Now, someone in chat has asked, Mr. Sanjay has asked, why wouldn't they use the Artemis 3 depot for Artemis 4? And this is quite true. The problem with this is that Artemis 4, the Artemis schedule as it stands, is always subject to delays. Recently, Artemis 2 was delayed to 2026, April 2026. I'm personally quite partial to believing it's going to be delayed much longer than that. Um, but, of course, we don't know. And I believe Artemis 4 is scheduled for 20, not a little bit after 2030, somewhere around 2030, which would be a year to a 2 year gap in the Artemis flight cadence. This is currently because it would be switching over from the existing SLS Block 1 to the new SLS Block 1B, which would feature the exploration first stage. However, of course, talking about SLS at the moment, somewhat dangerous to talk about that because the future is very, very uncertain.
A comment from Derek Wood on the YouTube says, biggest problem with depots will be maintenance. If a depot develops a problem, do you throw it away or do you need a human to repair? I mean, given how often SpaceX is going to be launching, I guess they could just send up another one. But I could see on-orbit maintenance becoming quite easy with Starship, to be fair. You've got such a massive vehicle with possibly so many little cargo compartments. And depots themselves aren't tremendously complicated, are they? Really, it's just a bunch of big fuel tanks with some valves.
Honestly, oh, sorry.
Go ahead, Jacob.
Like similar to how SpaceX has been manufacturing like Starlink satellites on this massive production line, how they might plan to do the same with Raptor engines. I could definitely see like just a constant stream of depots coming out. Maybe not on the same scale as those two things because those are kind of small, but for all these uses that they seem to have, especially for the Artemis program, it would be probably smart to keep like a stockpile on hand. So it's
This
yeah.
is incredibly true. SpaceX has talked about wanting to eventually produce a ship per day from their Star Factory in Texas, and eventually with their Star Factory in Florida, bring that production rate up eventually to around 1,000 ships per year. Now, of course, the thing is with ships, these are all very different purpose. A ship does not equal a ship. As I have written too many times in a script for a video I eventually wish to produce. They have different purposes, of course. There are standard cargo starships, there are tanker starships. All of these really, what will differentiate them is what they carry in their own payload compartments. A true ship for perhaps commercial cargo will have large bay doors that will reveal the whole nose cone, while a ship designed for exact like Starlink will have the small pez, while as a tanker might just have a hollow nose cone entirely. Um, of course, a ship for Mars will have legs. These are all slight differences that, while they contain most of a very, very similar building block, these will all need to be slightly specialized. And the thing is, depots will need to be a somewhat more specialized production line. But when you think about it, there don't really need to be an excessively large number of depots. Because if you're thinking about it, when SpaceX is aiming to send people to Mars, they want to send 100 people on a single Starship. Now, while that might be considered extremely silly, it is what they are intending to do, and is still clearly what they are intending to do based on what we've heard from the HLS program. Again, another fine render from the space engineer shows that what we can see with 20 bunks in a circle designed to have 5 rings of those, 100 people to Mars per flight. Now, when you think about this, if you want 1,000 people on Mars, which would be quite ambitious, extremely ambitious, you would only need 10 starships for that. You would only need 10 starships of crew to do that, and that would allow cruise ships, etc., to be in a very smaller rate-limited period. Maybe at most, let's say you want an individualized depot for every single starship. That's only 10 depots total. It's very different from what we'd expect. when you're thinking about Mars production. But most crucially, when you think about it, the cargo is the big part because what people don't mention as often with the Starship architecture is how much of it is built on this idea of pre-supply. So I'm sure that you've heard of like resupply, for example, to the International Space Station, right? Resupply is when you, of course, just send replenishment, food, water, fresh clothes up to a space station or another location just to get fresh supplies in the area. However, pre-supply is an example SpaceX has of sending things to the location before they become critical so that once people land, they need to use all of this equipment, which will help them come back, do what they need to do. On Starship now, we know that they are preparing for ISRU. We've seen um, stuff for fuel air respiration plants, which both will have utility on Earth and on Mars. They're designed to suck the carbon dioxide from the air and separate them out into liquid methane and oxygen to, of course, refuel the Starship, which on Earth will allow Starship to be very close to carbon neutral, or at least as carbon neutral as you can get. And on Mars will, of course, just allow the Starships to get home, period. These things will need to be landed on Mars ahead of time. They can either be set up by colonists or set up robotically. It looks increasingly like robotically is a preferred option because, you know, human beings are a very expensive commodity to keep around, and building things robotically is certainly at least more optimal in that sense.
Just interrupting you quickly to say that SpaceX has just tweeted and confirmed that they go for propellant load. That explains the venting.
Continuing
Nice.
on. Another thing that will have to be delivered to the Martian surface is power. There is some speculation as to how this will be done. However, people often like to speculate very much that it will be done with fission power or some other kind of constant supply. However, something crucial to understand is that SpaceX need not play by those exact rules because what they have on their side is scale. For example, the Starlink V3 constellation will have, I don't remember the exact size, but I think it's over 30 meters squared per satellite of solar panel area alone per satellite, and that will have over it's around 30,000 satellites total, which will just mean that they're producing so many solar panels per year. And because, of course, Starlink has to go around the back of the Earth, they will be providing tons of batteries as well. They will have production materials and the ability to just start scaling up and scaling up. These things, again, they're going to be massive, but the thing that's very nice about the Starship architecture that Elon Musk has said many times is that the metric that is most crucial is mass to the Martian surface. 100 tons on Starship once isn't a big problem. Again, 100 tons of payload, right? That is a huge number. That is an incredible amount of energy or batteries or solar panels that you'll be able to smack into just one small area. An incredible ISRU plant, etc. It's huge. A huge amount.
Snacks.
Sorry, what was that, Quantum?
Just said, or a lot of snacks.
Yeah, exactly. Uh, Actually, that is another very important thing. Food, stuff like that, etc., also needs to be shipped with it. All of these elements. Sorry for ranting so much. As you might be able to tell, I've had these thoughts in my head about the Starship architecture. Um, they are they are quite large. They are quite large, and all of them are planned to just use the insanely high cadence of Starship to get as much stuff onto the surface of the of the of Mars as possible and build up a civilization from there. Of course, but you know, that's a bit that's how it's designed to go, of course, and we're just simply watching one Starship prepare for its next flight. But of course, it's extremely fun to dream.
Just a quick comment from Sanjay Jairam here from YouTube. He's asking if Starlink's V3 solar panels are larger than Juno's. The individual panels are, but Juno had 3 of those solar panels, so it still generates a little bit more power. Hello from the Philippines from S-Flight-X. Hello, Mr. S-Flight-X. Welcome. We are 57 minutes away from launch with not an awful lot going on, but things should start to speed up soon.
SpaceX will start streaming around, what is it, in 30 minutes into the count. So if you...
A man can dream.
Yes, if you despise us, of course, we might be slightly more out of hair in a little bit, but until then, I think we will continue to speak.
To blabble, to ramble on.
Exactly.
I have a... Sorry, I keep interrupting. It's just because my internet's so bad.
Keeping us going. Carry on.
This might be a bit silly, but obviously SpaceX is planning to have a lot of starships, right? So, I was wondering if maybe you'd think when they start developing crew starships that they might have, like, say the ESA wants to purchase one or purchase the rights to use one. That's just the ESA's starship kind of thing. Do you think they'd have these international partnerships with these different space companies? Well, not space companies, just space incorporations, kind of, for that purpose?
Well, I mean, SpaceX is a launch company selling launch services at the end of the day, with some other little kind of side gigs like Starlink. I could definitely see organizations purchasing space and capacity for like long-term experiments on starships, but I don't think entire starships themselves would be bought out. Maybe a depot or two for scrap purposes, but again, I could see SpaceX probably removing engines first.
There goes my dream of Canadian Starship.
And why would you make Starship worse?
Okay.
All right. Look, I'm sorry. I'm the only American in this call, and that, of course, means it's my turn to be ardently nationalistic. Well,
We've gotten so bored that we've devolved into nationalism. That is
Of
T-minus
course.
55 minutes happening.
Of course. That's, of course, what you love this stream for. Now, in response to Jacob's question, I think actually that there is a good possibility that SpaceX will end up renting specific, or even allowing people to purchase specific starships for crew. You've seen this with things like Resilience, the Dragon, that was used on Inspiration 4, Polaris Dawn, and will be now used on Fram 4. No, sorry, Fram 1. It's a very, not exactly an exclusive Dragon, you might say. However, this Dragon is much more private. I have a feeling that for things like Axiom, for example, by the way, does buy specific Dragon missions and then rents them out to nations and organizations that are attempting to get their own feet into space. I imagine that the businesses there, SpaceX would certainly leap an opportunity to increase their rate of cruise ship production per year, because, of course, will be a very important driver for end goal costs of people to Mars. And beyond that, just allowing them to get more revenue, of course, just a phenomenal thing for the company in general.
I have another thing to say. Not really a question, more just like a statement or an idea, and I want to get you guys' opinion. Yeah. Going back to depots, they're built for on-orbit operations, and we are talking about wet labs earlier. Do you think that converting a depot into a wet lab would be feasible as, like, not inexpensive, but kind of a cheaper? Inexpensive and cheaper are the same words. I'm losing it.
I mean, no, to be fair, you're taking what was a pressurized tank and turning it into a pressurized tank. So I'd say it could be done. I'm sure there's a market for it.
Yeah, that's what I was thinking. And the cool thing about Starship is just how much room it has. A station developed from it. Sorry, my house might be a bit loud right now.
It's fine. It's ambience.
Yeah. Okay. Sorry, lost myself there. the stations developed from it will have such massive diameter that they could be used for all kinds of experiments that weren't even possible before with the ISS or even Skylab, which would be awesome. Where was I going with this tangent? Oh yeah. Um, nope, lost it.
It's a valiant effort. Look, I think you're holding it together more than I am, because I'm starting to tweak out. Well, 52 minutes. I'm not sure I can wait that long, man.
Yep.
Yeah, it will be interesting. I remember seeing those old videos from Skylab of them bouncing around and showing off like gyroscopic motion of their bodies, and the moment I see that with Starship, my life will be complete. That'll be great.
Right, that just reminded me of it. I've seen in like the Vast ideas, like the Vast the company, not the descriptor, that they plan to make like rotating space stations to generate gravity. Do you think this would be feasible with Starship up to a certain amount of gravity? Because obviously it's a smaller space compared to all these sci-fi ideas, and if you get it spinning too fast, you're gonna have a couple, like, puking astronauts.
I recall there was an idea to tether starships together, wasn't there? And to have them spin about a point and use that as kind of artificial gravity. But to be honest with you, I think artificial gravity in general is a bit of I don't know, man. I think it's more fashion than function. Realistically, if you need it, you're going to be in space stations for a very, very long time. And in those cases, why not just develop a specialized vehicle instead of using an old Starship hull?
That's true. That's true.
The one advantage that tethering two starships gives you, I guess, is you have a really massive diameter, which with propellers effect. You're always going to have some propellers effect. It will still mess up.
Really true. Alright, I'm back. So, okay. On the topic of artificial gravity, there are experiments coming up in that domain in the coming years. So, first of all, we know that Vast is preparing to launch their own Haven space station, which is supposed to debut microgravity experiments by tumbling the station end over end. This will not necessarily be with people on board. I believe this is planned for uncrewed demonstrators. However, this will, again, for research. Another thing in artificial gravity, I believe Airbus and their Loop module, which I believe is going to be the basis of Starlab, the Starlab station that SpaceX has agreed to launch, is advertised as having a specialized area bomb that functions as a centrifuge. Artificial gravity is some promising technology. The biggest response to artificial gravity is always, well, then just spend less time between planets. However, that's not always the best or most efficient way. Of course, comfort should be prioritized. Now, some studies that come out report artificial gravity working very well for things like just even half gravity being enough to keep like 75% of your muscle strength and function. Perhaps muscle loss doesn't scale linearly with gravity loss. We simply do not know. However, with experiments like these kicking off, we're going to find out and we're going to get much, much more reliable data. Now, um, things, for example, like Blue Origin, eventually, they want to build these large, like O'Neill cylinders, Stanford toruses, these kind of giant orbital megastructures. And these, of course, will rely on artificial gravity. SpaceX, on the other hand, much more planted their feet in the ground, so to speak, and are much more dedicated to the idea of going and staying on planets. Jacob, I know you have some. I know that you've read quite a bit on these various Mars studies. Anything particularly that would stand out to you as interesting, or concepts that you'd find interesting around artificial gravity?
Um, you, I think we pretty much encapsulated all the ideas that I'd have. Something neat that I saw was using a module, not Starship size, something larger, to generate Mars's gravity on the way out there, even for brief periods, to get the astronauts like adjusted to that gravity, so they don't land on Mars after 0 G and like get all dizzy for a couple days because they're still readjusting. Like slowly acclimatizing them over time. And I've also seen concepts of this is more sci-fi than anything. This is scientific, but um, yep, it's sci-fi, the most imaginative form of speculation. I've seen ideas for spaceships in Earth gravity, well, not in Earth gravity, in Earth orbit, that rotate at the speeds of the Moon and Mars, and you could first test the technologies on that station that you intend to bring to Mars to see if they'd function, and they replicate the conditions like really well, a way you can't do it on Earth, before they send it over there just due to the cost. But again, if you're sending 150 tons at a time, it doesn't really matter. So Starship kind of
Force your way
overrules
through
that.
it. I
Exactly.
do want to. I do. Oh,
Oh,
go on, Virgin.
propellant loading has begun on the ship.
Excellent. So we're going to get chilly. I do want to interrupt this little chat for some comic relief. I believe if I pray to the streaming gods that be, they might put up a graphic of the earliest proposal for Starship Block 3. There it is. Can we
Ah,
laugh at this thing for a moment?
oh,
I can't.
imagine. Oh, it's horrible.
I'll be
Oh
completely
no.
honest with you. I can't take that seriously in the slightest. Comically long Starship.
Yeah, no. Comically, extremely comically long starship. The pain.
I think the
The
big
pain is
problem is
this.
there's nothing functionally terrible about it. I mean, I'm sure they can validate their aerodynamic models, and I'm sure they can size the things properly. I'm sure it would work, but it just makes me feel very unhappy. Space Vulture has described it as so sicko mode. I'm not endorsing that.
It's great and it's terrible. You know, it's got its own quirks. The thing that Elon Musk said, if it were to ever stretch that much, it would just need to go to just blatantly just go to a wider diameter, such a like a wider diameter ship is certainly on the table from what we've seen. It would, of course, be a massive new undertaking. It would require a lot of new development, but a lot of lessons from the Starship program could be inherited to this new program because, of course, not everyone knows as much. Again, like nobody knew how complex Starship would have to be, and of course, some of it would scale. Not all of it would scale, but some of it, of course, would scale. And with things like this, you can just see how absurd it would get, and how perhaps a wider ship would fix this.
Reminds me a little bit of Falcon 9 and how that kept extending with full thrust and Block 5. And now I think it's one of the thinnest rockets in the world for its length, actually, isn't it? It's
Yes,
kind
yes,
of
it
absurd.
is. Yeah,
And the
it
fact
is.
it can survive that dynamic loading as well scares me a little bit. I suspect Starship might have a lot more dynamic loading, so I'm not sure it'll be as thin.
Yeah, yeah. The biggest thing about Starship, and I mean, this isn't as large as, what is it? This isn't as large as, long as Falcon would be, fineness ratio wise. It would still have a bit to grow. If you can recall, some of the biggest things going back to Raptor 3, you can see how, again, with V2 booster, just all of that shielding being removed, all of that business getting removed. Just, whew, whew, going
I
to
am
be
still
quite
waiting
a
for
day.
Starship Heavy.
Oh no, don't even start with that. Starship Heavy, ugh, horrifying. When version 2 hardware on the booster starts rolling out, it will be a very entertaining. Um, Speaking of a version 2 booster, the second pad for Starship is it's out and about. It's getting worked on currently. It's apparently slated for introduction before the end of the year. And it, well, I mean, in its current form, it will support Starship. It will support Block 2 Starship specifically. And it will get the Raptor 3s up and running. Version 1 boosters, as we've seen now, will likely not be compatible with this next version. Um, anyone else here know any particular changes that are coming to the launch mount that we've been able to just see visually?
I'll interrupt quickly to pray to the streaming gods that be if we could possibly take a look at this launch tower in question.
Ah, yes, of course, of course. There we go. There we go. We can see some of the big details on the tower. Of course, you can see the ship quick disconnect, which is of course terribly mutilated after the many eons of stretching that have occurred on the poor ship. Um, on the next Tower B, Tower 2, whatever you want to call it, because frankly it has so many names that I just can't keep them straight anymore. Um, it will have shorter chopsticks, have properly aligned ship disconnect port, and
No way.
will generally be much more stable than the current tower.
I'll start to see Starship getting a little bit frostier now as propellant gets loaded, which will be fun.
Excellent, excellent. Yeah, we should be coming up on much faster propellant loading now, and in about 10 minutes we should be getting the beginning of the SpaceX stream. So, if you have any questions that you'd like for us to get answered, feel free to ask them now because never as good of a time.
If you're just joining us now, don't worry, you haven't missed the launch. It's still on the ground as far as I can tell. We're at T-minus 40 minutes, and the SpaceX stream's hopefully starting rather shortly where we'll get some more updated information. Ship propellant loading is underway.
Very much so. Right. Well, shout out, yes. Civilian Space said as shout out to just the letter K. Been amazing with the Starship keychains. Yes, no. Shout out to just the letter K. Phenomenal member of IGW. Very nice person in general. Shout out to her. Thank you, Daniel, for the 3.99 super chat. Again, thank you guys.
Oh, whole buckaroonies. Take a look at that, will you? That's nice.
Exactly. Thank you. Thank you very much. We appreciate it a lot to keep the stream running. Thank you guys. Okay. Sanjay has a question in chat. When do you guys think the first star? Oh,
The internet
sorry.
gods appear to have taken Perigee.
Oh no. Oh no. How terrible. Okay.
They've
When do you?
returned him.
Oh god. Okay. When do you think the first Starship will launch from the second tower? My thought on that is probably during the second half of this year. Probably very close to the second half of this year. Oop. I think you guys might want to check.
SpaceX has just gone live, kind of in the
Yep.
starry background.
There we go. I could tell immediately because the viewership dropped. Alrighty. Well.
No, don't leave. We'll be good, I promise.
All
I'll be better. Oh, best of luck with the color grading, Daniel. I've spent too long taking a look at the Da Vinci color page. The wheels are burned into my mind, man.
Alrighty. Well, here we go.
T-minus 38 minutes. Everything still looks on track, which is great.
Alrighty. Well, that will be its own mess. Thank you all. So many of you actually, for sticking with us. This is not. We've retained a much higher percentage of viewership than normal post the stream happening. So thank you guys very much. Of course, thank you, Quantify. You
All down to
personally
me.
are responsible.
Mhm.
Yes, course,
My
the most.
flock of followers followed me like fanboys and fangirls. I've actually got a few at my door right now waiting to get an autograph.
Incredible. Okay, well, is SpaceX live or not? Oh, good lord. Oh, it's been pushed to 57. Sorry. Stream still. Sorry, stream is begun. It's
What are you saying, my
30.
man? I think the Starship fever is getting to you, Mr. Perigee.
Agreed. You know what I need?
No,
I need water. This stream is sponsored by good old H2O. Stay hydrated, everybody.
For legal reasons, that's not a company, that was a satirical joke.
Yes, no,
Yes,
I do not.
SpaceX is live, but it's just the current starry sky background. There's nothing happening.
Exactly. For legal purposes, I do not believe that a molecule of H2O would be able to sponsor a.
Oh, look at that! We've made it onto i3 Lou's big screen. Hell yeah!
Hell yeah! Also, again, I3 Lou, thank you again for the memberships that you donated earlier. Very much appreciative. Memberships, it's a great way to support IGW. So thank you. All right. Well, one day, perhaps Starship may decide to start streaming, but that day is not today. Well, not today. Sorry. Oh, God. Not right now. Not this exact. Lord.
That minute is not this minute.
Exactly.
It's not the second.
Speaking of minutes, we are launching at about, what time is it now in my time zone? It is 5 p.m. right now. So that means where the Starship's been landing for the last little while, it's going to be day. So we're going to have a nice, beautiful day re-entry, hopefully.
Speaking of minutes, it's such a good segue.
Oh, I've got another segue for you. Let me cook one up. Speaking of re-entry, this payload, these Starlink test satellites, they're not going to be put into, not satellites, payload simulators. They're not going to be put directly into orbit, right? They're going to be put, and they're going to re-enter with a Starship? Or...
Yeah, they are being ejected on a suborbital trajectory.
Yeah, I thought so. Just putting chunks of metal into orbit.
Ah, well, SpaceX has begun the stream, ladies and gents.
Oh.
Using beautiful video that we know. Pretty.
Any of you have ever played Global Space Program and had a rocket absolutely fail and thought, you know what, I'm just going to stage everything anyway for fun? It's kind of what SpaceX are doing with those mass simulators. There's basically 10 little things that are going to re-enter along. Pretty cool, if it's caught on camera.
Imagine that they'll have something cooking up. Of course, we can see the current views. One of my favorite parts of this video is how the Booster 13 static fire is omitted. Very, very slightly, I believe, after they are legally allowed to. But, you know, of course, gotta love SpaceX for it.
Yeah, things happen. You move fast, you break things. So
Breaking
regulation sometimes.
To the law. All right. I think we'll shut up now.
You can see the rocket behind us. It's mind-blowing. This is quite the view, Dan.
No better seat in the house, no better thing to talk about a rocket as you watch it launch. Hi, everybody. Welcome back to Starbase for another Starship launch. I'm Dan Hewitt from SpaceX Communications. We are at T-minus under 33 minutes and counting. Our T0 time coming a little after the bottom of the hour. Now, Starship program has brought us nonstop excitement back in 2024. This year shaping up to be even bigger.
Absolutely. We're looking at even more launches of Starship this year with tons of exciting firsts starting today. Flight 7 has a lot in store, from Starship's next generation upper stage design on its first flight today to deploying the first simulated Starlink satellites and the second booster catch attempt. We're kicking off 2025 in style here in the Lone Star State. So hold on to your butts because it's going to be a wild year.
And it's all ramping up as we chase after that full reusability for the world's biggest rocket. And we're going to be with you today every step of the way. Also joining us, though, amid a very excited crowd growing over there in Hawthorne, is Jesse Anderson. Jesse, how's everything going in LA?
Hey, Dan and Kate, everything is all good here on the factory floor. We're just outside of mission control, and we're T-minus 31 minutes away, but we already have a really big crowd here building. There you go. Starting to build up here. Every flight of Starship has made huge progress, and today is another exciting one. We're joined by Starship, Raptor, and Starlink teams here with me today, and everyone is getting super excited for this flight test. So with that in mind, I expect it to get very loud in here soon. But for now, I'm going to hand it back over to you guys at Starbase for a quick look back at the flights that brought us here today.
Hey, thanks, Jesse. Now, the more we fly safely, the faster we learn, the sooner we realize full and rapid reuse. The previous 6 flight tests proved we're on the right track. Each one of those tests provides a ton of invaluable data and, of course, some pretty great views along the way.
Oh, yeah. Every one of those tests informed the upgrades that are debuting on today's flight test. And you know, we've all been watching this, following through the incredible testing campaign for every flight. And man, I can't wait for today as well as everything else we've got planned this year.
Just a recap of what happened just before this flight test. Our most recent one was back in November 19th. That was Flight 6. It lifted off at 4 p.m. Central from Starbase, Texas, just a couple miles over our shoulders.
It was a gorgeous sunset ascent. Let's take a look.
Startup and shutdown. Starship is at 100 kilometers altitude. Flaps now have control of the vehicle. Starship has started the subsonic belly flop.
Today's flight test is going to look pretty similar profile-wise to that last one and honestly the last couple. So everything starts off, as always, with liftoff. The Super Heavy igniting those 33 Raptor engines. Super Heavy going to power us through that initial ascent, get Starship on its way to space before we get to the hot stage maneuver.
Exactly. The ship will then ignite engines while it's still attached to the booster That will allow us to separate the two stages. That booster will leave a few engines on for that flip and return back here to Starbase for a catch at the launch tower.
And while booster catch is blowing our minds, ship keeps going all the way to space, gets into its suborbital trajectory. Got a couple on-orbit things. We're going to deploy our first test satellites. Also going to relight a Raptor engine while in space. That all sets us up then for re-entry.
As we have seen on the previous flights, courtesy of Starlink, that re-entry period gives us such gorgeous views. It's like, you know, just a rainbow flow of colors as the ship re-enters the Earth's atmosphere. The ship will relight its engines, perform a flip maneuver for a soft water landing in our targeted location in the Indian Ocean. And that will once again be daylight given our later launch window. So today's flight test will be launching the next generation of Starship. It'll attempt the first payload deployment test, fly multiple re-entry experiments geared toward ship catch and reuse, and of course, the launch and return of the Super Heavy booster back to the launch site right there behind us.
Yeah, that's going to be amazing, but ship, kind of the star of the show for a lot of stuff today. A huge block of upgrades to Starship's upper stage are debuting on this flight test, adding more capability. We'll start off up top. Those forward flaps got a redesign. They shrunk in size. We shifted them towards the top of the vehicle, away from the heat shield. That's going to make it significantly less exposed to re-entry heating. And then Starship itself, we made it about 2 meters taller. So we stretched it up to about 52 meters. That allowed us to add 25% more propellant volume, along with a bunch of propulsion upgrades like vacuum jacketing of those feed lines to the engines, an entirely new feed line system for the Raptor vacuum engines, an improved avionics module for propulsion, all that adding performance and the ability to fly longer missions.
And just like on Flight 6, tiles have been purposely removed to stress test vulnerable areas. This time we're doing it across the entire vehicle, including in critical areas, as we use this flight to push the boundaries of Starship's capabilities. And for re-entry experiments, multiple metallic tiles are being tested, as you can see there on your screen, including some that have a version with active cooling.
Then the vehicle's avionics, its brains, got a complete redesign. Some of the new things, we've got 4 of these upgraded Starlink terminals that combine Starlink, global navigation, and RF communications into a single unit. And then on the sides of the vehicle, we have these catch fittings. They're non-structural, but we're going to be able to see how they perform thermally during re-entry. We also smoothed part of that tile line to address some hot spots that we saw during entry on the last flight.
Now the ship and the booster, they weren't the only thing to get some upgrades. On the ground side, several radar sensors will be tested on the tower catch arms as we experiment with additional ways to measure distance between the arms and the vehicle while we prepare for ship catch. Now this is just a handful of the many upgrades included on this flight that make this the most capable Starship that we've flown so far.
And then something really cool has me super excited. We're going to be deploying 10 Starlink simulators that are similar in size to our next generation Starlink satellites. With pretty unparalleled payload capacity and full reusability, Starship's going to be able to deploy our more advanced V3 Starlink satellites, which is going to help us continue to revolutionize global connectivity. Each of those Starlink V3 launches on Starship is going to add about 60 terabits per second of capacity to the Starlink network. And that alone is that's more than 20 times the capacity we're getting with every V2 Mini flight on a Falcon 9 right now. That just helps further Starlink's impact in the coming years as we expand access to high-speed internet all around the world and eventually beyond. And those Starlink simulators are going to be on the same suborbital trajectory as Starship, and they're expected to demise upon entry. Starship itself, its trajectory looks very similar to all of our last several flights, suborbital, splashdown targeted into the Indian Ocean, a couple hundred miles off the western coast of Australia. And then the other on-orbit thing we're doing is going to be relighting a single Raptor engine while in space. We knocked that out last time. V2 ship, new propellant system. Let's do it again on this one.
Ship's going to be busy. Now, of course, we can't forget to add that today's Super Heavy booster is reflying flight-proven hardware for the first time. A Raptor engine that flew on the booster that was caught during Starship's 5th flight test. You can see it there on your screen. This flight-proven engine, we've got Raptor 314 there, hence why there's a piece of pie on this nozzle. Maybe we can get that image rotated so you can see it a little bit better. Yep. There we go. If you didn't already know, we like our jokes around here. So that's what we have planned for today's flight test, and so far everything is on track as we continue to count down. We're now within 23 minutes of launch. We're at 22 minutes and 52 seconds. Everything continues to look good. Still a little breezy, but that's okay for us.
Yeah, we set up our desk in a wind tunnel today. It's probably windier here than it is anywhere else, but weather's cooperating, really clear skies, no rain today, still well within our limits for booster launch or catch. Not tracking any issues on vehicle as we continue to count down. We're still loading prop on board. Our range team also reporting that the range looks like it will be clear at our current T0. So that's super important. We're going to keep an eye on that all the way up to the end.
As for what we've already done with the vehicle leading up to today, we stacked the vehicle over the weekend. We lifted the ship on top of the Super Heavy booster. Hours ago, we cleared the site of all personnel, and of course, our flight controllers came on console, some of them sitting in the building behind Dan and I. And as Dan mentioned, the range team was deployed. They are standing by in the Gulf to make sure that the booster has a clear to return back to here at the launch tower, but also they're located in the Indian Ocean, standing by to make sure that the targeted landing zone for the ship is also clear as well.
And then we knock out a whole bunch of things in the hours before launch. We do an alignment on all the guidance, navigation, and control. We did tank purges, pressure checkouts, make sure we were ready for prop load, check the booster, quick disconnects, and the ship one. We demate the chopsticks. We actually do a little wiggle check on them, make sure we have control, as we're going to be using those for catch. Load up all of the hydraulics that are on the tower, and then we did the initial locks and methane chills, getting them ready for prop load.
Now, speaking of prop load, we conducted the go, no-go poll for prop load at 3:30, so a little bit less than an hour ago. All was good there. Prop load is underway. The LOX load on the booster started at T-minus 45 minutes, and fuel started at T-minus 43 minutes. Booster fuel will start at T-minus 41 minutes, and then LOX on the booster started at T-minus 35. So that will all wrap up at T-minus 3 minutes and 20 minutes on the ship side, and at T-minus 2 minutes and 50 seconds on the booster side. So everything is looking good. Propellant is loading.
Yeah, looks like we're about half full of everything on booster, 3/4 of the way there on ship, looking good for a launch today. With that, though, let's jump over. Let's check back in with Jesse real quick and all of our teams out at Hawthorne.
Thanks, Dan and Kate, and great to hear the updates with the vehicle as we prepare for liftoff. There is a lot more people here, as expected. Love it. All the Raptor engines are built here, so there's a lot of that team here in the crowd, so they have a strong connection to the Starship flight today. Every flight test gets us closer to a fully operational Starship, which gets us closer to our ultimate goal to make humanity a multiplanetary species. To establish cities on Mars, we're going to need high-cadence, low-cost flights for cargo and crew. As the only fully reusable rocket with this kind of capability, Starship is the only vehicle in development that will be able to unlock our multi-planet future. Starship uses a first-of-its-kind on-orbit propellant transfer to refuel in orbit in preparation for these long trips. With milestones like ship catch and in-orbit prop transfer coming up, 2025 promises to be huge for Starship and our journey to Mars, with our first trip currently planned for the end of 2026. Between the reusability, low cost, and heavy lift capabilities, this all comes together to help us deliver up to 100 people at a time to destinations both near and far, and to deliver payloads farther and at a lower cost than any other vehicle. we'll be able to launch more massive payloads than anything else flying or in development today, capable of sending things like giant space telescopes or the next generations of space stations into orbit on a single launch. So while today's flight is just a test, the future is much closer than we realize. But one flight test at a time. So let's head back to Dan and Kate for a closer look at Starship.
Thanks, Jesse. Starship features two major parts: the ship, which has 6 Raptor engines, and the Super Heavy booster, which has 33 Raptor engines. The Raptor engine is a reusable methane-oxygen staged combustion engine that powers the Starship system and has twice the thrust of the Falcon 9 Merlin engine. Now, just like we saw flights 1 through 6, the current iteration of Starship is an experimental vehicle flying for development. As we mentioned earlier, today's flight is debuting a ton of upgrades that we've had in the works in order to increase Starship's reliability and performance. Several of these upgrades will also unlock our ability to fly longer missions, something that we'll want to do as we start doing orbital flights around Earth.
And then to get an even better sense of just how big Starship is, we can start here. Let's take a person about 2 meters tall. Towering over that, you got your Millennium Falcon clocking in at 35. Just above that, we've got a Falcon 9 rocket, payload fairing attached. Double that height, you're up at 70 meters. And then topping it all off, nearly twice the size, it's a fully stacked Starship up to 123, got 2 meters taller. Altogether, the ship, 52 meters, Super Heavy boosters, 71. And what's super fun is we're going to make ship and booster even taller in the future.
Which is crazy, because turning around and looking at it and thinking that it's going to be bigger, that's mind-blowing.
Make the ship as tall as the booster.
Now, moving up the rocket, the ship features 6 Raptor engines. 3 optimized for sea level performance and 3 optimized for vacuum performance. Raptor Vacuum, or RVAC, is a similar design to the Raptor engine, but features a larger exhaust section and a larger expansion nozzle to maximize the engine's efficiency in space. Our upgraded ship that we're debuting today carries about 300 more tons of propellant than the last flight's ship, bumping it up from 1,200 metric tons to about 1,500 metric tons. It's a lot. The ship is designed for vertical takeoff and landing on any hard surface. Now, the ship is also outfitted with newly redesigned forward flaps that are used to aerodynamically control the vehicle's attitude during atmospheric flight and enable a precision landing. The new flaps are lighter and positioned more leeward or away from the heat shield.
Now, to reach full reusability, the ship has to be able to survive re-entry not just one time, but multiple times. The ship's heat shield is essentially what does the job for that. We've been iterating on that every single flight, building towards that heat shield that requires no refurbishment between flights. Now, the heat shield is composed of thousands of hexagonal ceramic tiles. They're designed to insulate the vehicle during that atmospheric entry where temperatures ramp up to as high as about 2,600 degrees Fahrenheit. A rapidly reusable heat shield has never been flown in history, so continuously improving this, flying new experiments, those are all key focuses of all of our flight tests right now.
And in between the first and second stages is our hot stage, which we saw in actions on flights 2 through 6. The hot staging maneuver is when the upper stage engines are ignited before the booster engines, before those booster engines are completely cut off. With hot staging, the rocket never stops accelerating during separation, so it's more efficient than traditional stage separation. One of the hallmarks of Starship flights are the incredible views that we get throughout flight, of course, courtesy of Starlink. Every day, we're working to expand the Starlink network, both on Earth and in space. Here's Jesse with more.
Fans of Starship may know that Starlink enables us to bring you lots of unprecedented views, both from space and here on Earth. In addition to the dozens of cameras on Starship itself, we also have mobile Starlink camera kits deployed in the Indian Ocean, connected to our aerial assets and all around Starbase, which all come together to help tell the incredible story of Starship, both on and off planet. Thanks to Starlink, Starship is capable of streaming more than 120 megabits of real-time, high-definition video and telemetry in every phase of flight, providing invaluable engineering data to help engineers rapidly iterate across all systems. And all of that streaming data will be put to good use with the more than 30 cameras on the vehicle for today's flight test. Starlink is the world's largest satellite constellation, operating in low Earth orbit to deliver high-speed, low-latency broadband internet, providing access to people around the world, many who have never had connectivity before. Starlink now serves more than 119 countries, territories, and other markets. And here at SpaceX, we've been developing Starlink's communication capabilities not just for humans on Earth, but for astronauts in space. Our recent Polaris Dawn mission, we deployed a high-speed internet connection in Dragon for the very first time. From connecting astronauts in space to providing high-speed internet to more than 4.6 million active customers here on Earth, the Starlink team is laser-focused on expanding coverage, increasing speeds, and lowering latency so that we can connect as many as possible around the world and beyond. Last year, we activated Starlink in 27 new markets and are now covering a global area home to 2.8 billion people, including those who live in some of the most remote places on Earth. To meet the growing global demand for high-speed internet, SpaceX opened a new 700,000 square foot factory in Bastrop, Texas, and introduced Starlink Mini as well as an upgraded version of the Starlink Standard Kit. The SpaceX team also achieved an unprecedented launch cadence, conducting 134 Falcon launches, with 89 dedicated to expanding the Starlink constellation. With each launch, Starlink adds more capacity to the constellation and continues to expand its coverage, connecting even more people in underserved and hardest to reach areas of the globe. Now, while our mission to connect the unconnected is far from complete, you can check out some of the Starlink team's highlights from 2024 and learn more about how our customers are furthering Starlink's impact around the world at starlink.com/stories. And a little bit closer to home, we do have a few updates for those impacted by the fires here in Southern California. So far, the Starlink team has provided about 1,350 free kits to fire departments and other disaster response organizations from down in Orange County all the way up to Malibu. That is in addition to applying free Starlink service for thousands of customers impacted by the fires all across the Los Angeles area. And just as critically, since enabling our direct-to-cell satellites with T-Mobile, more than 120,000 text messages have been sent, allowing those in impacted areas to reach loved ones, text 911, or receive emergency alerts. I've never been prouder to be an employee at SpaceX for moments like that where we can help the people and community around us. Make sure to follow at Starlink on X for updates as we continue to work with local response teams, and check out starlink.com/LA wildfires for more information on these efforts. But back to today's flight test, one of our objectives is to return the booster to the launch site where it will be caught by the tower as we did on flight test 5. So let's head back to Dan and Kate for a catch primer.
Thanks, Jesse. We are now T-minus 8 minutes and 40 seconds until liftoff. Flight controllers on console there in the building just behind Dan and I. You can actually see the rocket in the distance at the pad 6 miles away. Our excitement is growing. I already am not sure if I'm going to be able to remain coherent after witnessing this, so looking forward to it.
You'll be all right. You'll be all right. Just a quick status check. The ship fully loaded in its main tanks on LOX and fuel. We're going to load the header tanks, and booster is going to be closing out real soon as well. Let's talk about that second catch attempt, though. So we're going to use the tower's 2 gigantic robotic arms, call them the chopsticks, same thing we used to stack Starship onto Super Heavy for all the integration ahead of a flight, and that's what we used to catch by moving stuff like landing legs from the booster to the ground side. It's a lighter booster, means you can carry more into space.
Now, in a nominal operational scenario following liftoff and after the 2 stages separate in flight, Super Heavy will return to the launch site, reignite its engines to slow the vehicle down, and the tower's arms will catch the rocket booster.
And just to get to this point, just like before, thousands of distinct vehicle pad criteria have to be met prior to that return and catch. We need healthy systems on the booster, healthy systems on the tower, and a manual command from our mission flight director for the day. If we don't send that command before the boost back burn ends, or if any of those automated checks kick us out, that's what happened on Flight 6, the Super Heavy booster will divert to an offshore trajectory, and it'll go out and do a landing burn in a soft splashdown in the Gulf of Mexico.
Now, we have said it before, but it remains true today. We accept no compromises when it comes to ensuring the safety of the public and our team, and that return will only take place if the conditions are right.
And one of the unique aspects of Starship flights is the return and the catch of that Super Heavy booster and the audible sonic boom that it comes with it in the area around the return location. General impact to anyone in the area is just a brief thunder-like noise, but it definitely lets you know it's coming.
Oh, yeah. It's something our neighbors in Cape Canaveral, Florida, and Vandenberg, California have become accustomed to over the years, and now we're bringing the boom to Boca. So here's a peek of what to expect.
As I mentioned earlier, we have Starship, Raptor, and Starlink employees here fully invested in this flight test. And of course, many other SpaceX employees also here across our site supporting their teammates. Every flight test has been pretty unique, and we're all very excited for another round of firsts, but I'm pretty sure the crowd is looking forward to potentially watching those chopsticks catch another booster. So let's see how excited they are today. Just under 5 minutes to go. We are all very excited here. We're going to send it back to you at Starbase for the final minutes of the countdown. Kate and Dan.
All right, thank you, Jesse. So if you just tuned in under 5 minutes ago, you picked the right time to do it. Just a quick status check. So we're almost fully loaded on the booster. We'll be fully loaded on the ship, fully loaded on the booster coming up soon. Our range team just reported that we're looking go in the range. That's super important.
Great
Our
news.
security guys, Mike, Kyle, Nick, the whole team out there in the elements, making sure everything's clear, doing a fantastic job. And we are coming up on 4 minutes and looking good for launch.
Yeah, certainly exciting. Now, we do have an opportunity to hold at T-minus 40 seconds if necessary. This is a chance for us to perform additional checks if necessary. If we, need to repressurize some tanks, or if there's a wayward vessel in the range last minute, opportunity to clear it out. But everything currently looking good. Now, once we pass T-minus 40 seconds, a number of events will occur in rapid succession. The ground spin and ignition systems come up to flight pressure. The ship will go to internal power. After that, the quick disconnect, or QD arm lockout, is removed in preparation for retraction, which will happen shortly after T0. And yeah, once we pass T-minus 40 seconds, we do have the ability to recycle the count under certain conditions back to that T-minus 40 second mark and hold there to assess what happened and assess opportunity to proceed again to T0.
Yep, we've used that T-minus 40 hold a couple of times. Boat's usually one of the items, but we aren't tracking anything right now that would cause us to hold there. We can hold there for several minutes. Main thing you're watching at is you kind of set a clock because your temperatures will change and the fuel in the locks, everything pretty quickly. So you've got a couple of minutes that you can hang out and figure things out. There are items that if we pass them, we're scrubbed for the day. One of the main ones is that flame deflector at the bottom of the launch mount. Water begins flowing for that at the T-minus 10 second mark. If we scrub at any point after that, we'll be done for the day. And then teams will need to refill the deflector as well as all of our prop that we use to load on board the vehicle. It's pretty much just under 11 million pounds of prop sitting on that thing right now. And we can actually recycle in about 24 hours now.
Which is incredible given the sheer volume of propellant that is on board the vehicle there on your screen.
All right, coming up on the 2-minute mark. Again, a lot of ambitious things on the plate for Starship today.
T-minus 2 minutes.
New ship, new year, a lot of upgrades, doing a lot of ambitious things in space this time. Our first payload deploy, relighting a Raptor engine. We're looking good.
So as we mentioned before, we have an opportunity to hold at T-minus 40 seconds, not tracking any issues at the moment that would be necessary right now. So fingers crossed we can pass through that checkpoint without stopping. But the folks on console are continuing to evaluate the launch commit criteria, making sure that the winds are within limits as well as any other weather restrictions. But man, compared to yesterday, this is a textbook gorgeous day.
Oh yeah, little breezy today, but we got clear blue skies for a launch today. So at this point, all the prop has been loaded on the vehicle. We've closed everything out. We're doing our final thrust vector control, our steering for the engine checkouts. Once we hit the 30-second mark, we'll hear the flight director give the final go for launch. So we're under a minute. As we said, we're not expecting a hold at T-minus 40, but do not be shocked if that happens. It has happened in the past, and we can hang out there for a couple of minutes if we need to.
If memory serves me right,
we hold my breath for 4 seconds.
Pass through prop load gate.
All right, we passed right through that prop load gate.
Hot diggity dog.
All right, so we're going to let our flight director, Ty Huntington, take it away.
Go for launch.
And 20 seconds.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have liftoff.
Vehicle's pitching downrange.
Booster check pressure is nominal.
All right, we're more than 30 seconds into flight. Telemetry showing 33 out of 33 engines as it's pitching downrange.
Booster ship, avionics power, telemetry nominal.
Hearing good call-outs on the ship and booster avionics. You just heard the rumble hitting us about 6 miles away. Watching Starship arc into just endless blue skies right now.
Vehicle supersonic.
More than a minute into flight, the vehicle's supersonic.
Max Q.
So we just passed through max Q. That's the greatest stress the vehicle's going to experience on the way uphill. Reminder that all of our teams down here on the ground are now looking at systems on the tower. They just did a manual check through. That's going to inform that manual flight director's decision. Next moment coming up, though, is going to be hot staging. Don't take your eyes off it. It's one heck of a light show.
What a gorgeous ascent.
6 ship engines getting ready to ignite. That's going to happen while we're still attached.
We can still see the ship's engines from the ground.
Got a little under 30 seconds away from that. We are hearing good call outs on the tower preparedness from the manual checks. Reminder though, we've still got automated checkouts on the booster and the ship itself. But as of right now, our manual checks and our manual commanding is looking go for a catch.
Booster engine cutoff.
That is incredible news. We just heard the call out for booster
Right,
engine
Nico.
cutoff.
Engine startup.
Most engines cut off, down to those
Stage
middle
separation.
3.
Cruise back burn startup.
All right, hot stage
Raptor, chamber
confirmed.
pressure
We've
is
got a
normal.
booster hopefully on our way back to us, and a ship now making its ascent burn into space. How's it going in Hawthorne, Jesse?
It's great over here. You can hear the crowd screaming for every milestone. The booster is now making its way back down to Earth. Looks like we have 12 of those 13 engines ignited. We're using the engines that actually gimbal.
We
So
are go for booster return.
an excellent call out there. We are go for booster
Ship
return.
avionics, power and telemetry nominal.
There's a lot of criteria that needed to line up to ensure that we could have a
Boost
safe
back burn shutdown.
booster catch, and it sounds like we got the go for that. And there you can see on your screen, we had we just jettisoned the hot stage, and there's a great, excellent view there of the hot stage floating away from the super heavy booster. Now we've shut down the engines for that boost back burn. That confirms boost back burn is now complete. That was the first of 2 burns required for the vehicle to make its way back down to Earth. And next coming up will be the landing burn. That's going to be 13 of those center engines igniting again. And that will then go down from 13 down to 3 engines just right before we touch down for that booster catch. Now, reminder, our stage 1 objectives are to have a controlled ascent, stage separation, as well as a controlled boost back burn and hot stage as well. So we're looking good for that so far. Some great views there from the ship of Earth. That looks incredible. Now, Starship's ship is still firing its engines right now.
Starship trajectory nominal.
And great call outs. Starship trajectory is nominal. You can follow along the telemetry, the altitude in the bottom left-hand corner for the super heavy booster, as well as the bottom right-hand corner for the ship. And these views are just amazing. Again, the booster is currently making its way back to the tower today. So we're looking forward to a booster catch with the chopsticks. And in the meantime, you can see those grid fins there, helping to control the vehicle and guide it back to its landing site.
Booster FTS is saved.
Now with that, we're going to hand it back. How's it going over there, Dan and Kate? How are you doing, Kate? Seeing that in person?
You know, Dan had to take that entire segment because I couldn't talk. That was incredible.
There it is.
We can see the booster coming back in now through the plume. At least it looks that way to us. It's incredible that it basically returns. It looks like a speeding, just like this silver flare coming back to the. Once again, we are standing by for attempting to catch the booster at the tower. This would be the second tower catch.
Booster
Landing burn. Seeing 13 engines.
Booster now hovering as it aligns with the tower for catch.
Booster coming in. Get
Down
ready
to
for that boom, Kate.
Down to 3 engines.
Booster landing burn shutdown. Megazilla has caught the booster.
You heard it here. Megazilla has caught the booster.
Once again, for the second time, a successful catch by the launch tower. This is the same tower, the launch pad, where that booster took off from just 7.5 minutes ago. Great view from the
Bullseye.
chopstick arms, looking at those hypersonic grid fins that steer the booster for that precision landing. It
And I
almost
mean,
looks
you
like it's
can-
flapping its
Yeah,
wings.
you can see just how small that catch fitting is too on something that's just so massive.
That was absolutely insane.
Meanwhile,
We're not done, but
We're
wait,
not
there's
done
more.
yet.
Wow, that is just absolutely stunning. And this, of course, a gorgeous view there from the tower looking down at the top of the booster.
all right, and we are tracking.
Now we're standing by for views from the ship, but who can take their eyes off of that incredible sight? That is once again the second catch of a booster back at the launch tower. It was incredible to see it come back down, just this silver flare in the sky. And we can still see the launch plume behind us, and wow, that we definitely, I can't speak for you, Dan, but that was very moving for me.
Yeah, and right now you can see some of the telemetry on those ship engines has gone out, and we're waiting for an update on what our ship status is. We were approaching that ship engine cutoff time, so just waiting to hear. So obviously we've got booster back, booster on the launch tower in the chopstick arms, but we are waiting to get an update now on the ship. As we were expecting ship engine cutoff about 40 seconds ago. We saw some of those engines start to go out prior to that point. And so right now we are just standing by to try and get the latest word on where we are with ships. So stick with us for just a couple of minutes as we wait to hear some updates.
Now, if you just recently joined us, you might want to hit rewind and go back about 9-10 minutes ago to when Starship lifted off from the launch tower that you see there. We had a gorgeous ascent followed by a stage separation where the ship separated from the super heavy booster. The booster performed a flip maneuver and returned back to the Gulf Coast here. There you can see it on your screen. Obviously a successful catch back at the launch tower, which is something that we were all hoping to see and really couldn't ask for a more beautiful background with those blue skies and blue water there. As Dan said, we are standing by for an update on the ship that had ignited its engines and started making its way up to space. So standing by for more info on that. But wow, what an experience to see that take off and for that booster to come back. You can see it there up close on your screen to the place that it launched from. Once again, there were thousands of catch commit criteria, which is basically just all the things that we have to assess and evaluate and basically make sure that they are make sure that everything is clear and acceptable conditions, both on the vehicle side as well as the tower side, in order to enable that catch. So obviously from the last 2 flights that we have done, where Flight 6 we attempted but had to divert into the ocean, and then on Flight 5 we did have the first ever successful catch of the booster. We used the learnings of those 2 flights to hone in that catch commit criteria, and we saw success today, which is pretty awesome.
And just a quick status check. So we currently do not have comms with the ship. So trying to figure out exactly when that happened and exactly what happened. So obviously the flight controllers right now going through their data, looking to make sure it's not anything instrumentation on the ship, but actually try and get us a status. So again, we're gonna keep listening in on this. We'll give you an update as soon as we have a little bit more. So for now, stage 1 back in the tower, waiting to find out a little bit more about stage 2.
Right, well, you're back with us until we get some more word from SpaceX, but yeah, that's worrying. I don't think it's in one piece anymore.
Yeah, no, ship likely gone.
I will say the failure pattern of the engines as they started failing was interesting. It looks like it was biased to one side, so if anything, it would have tumbled, I imagine.
Yeah, honestly, okay. Complete speculation. They did change the propellant distribution system to the RVACs.
So if you are just tuning in, we caught a booster.
They changed it.
But we are still waiting to find out a little bit more on the ship. So it had successfully separated. We did that hot staging maneuver. We did see all 6 of ship's engines on the way uphill during its ascent. But as we were getting to the end of that ascent burn, we saw engines dropping out on telemetry, and we have since lost contact with the ship. So again, we're still listening in on the loops, trying to figure out.
Hate to talk
how
over
much we
these
can get
fine
right
gentlemen.
now.
Our team has seen 2 bright lights falling from the sky. So upon tracking the ship, so very likely
unrelated phenomena.
Yeah, but we believe. Sorry. Yeah, no, 2 bright dots during boost back, both falling with HSR, sonic boom heard. Yeah, so there's a strong non-zero chance we saw the ship explode here. So I would expect probably something went wrong with the new propellant distribution system. However, booster caught. As you know, as it goes with SpaceX, man, this sucks. Flight 8 tomorrow. So
we'll be back here in 20 minutes.
Yeah, exactly. Would not expect this to be a major setback, ladies and gentlemen. In fact, I'd probably think they'll fly Booster 14 for the next one. So, whatever this is, it's new failure mode, new ship. This ship doesn't have the benefit of having most of the hardware tested through the SN program. So, there we go. We're going to see it. We're going to see changes. Stuff's coming up. Stuff's coming up.
Well, meanwhile, keep an eye on all the SpaceX social media channels, and also take a look at some of the kind of SpaceX enthusiast Twitters. They might have caught something that we didn't.
Very much.
We haven't gotten those bright dots on video, but our team has seen it, so we know they're there.
Yeah.
We'll be keeping an eye out to see any evidence.
Yeah. So, let's get ready. Let's get ready.
Bing Hampton says, so if we mix Starship and New Glenn, we'll have a success, and that thought makes me uncomfortable.
New ship or Star Glen?
New ship, new problems. Yep. There we go. Oh, hey, a portion of the aft flap was on fire. So that's fun.
I hate to do this to you, Mr. Perigee, but source?
Some gentlemen on Twitter.com have posted some pictures of the aft flap where you can see it's on fire. Very likely, yeah. This'll be a thing. New mishap investigation. This'll be an event. Yeah. Don't doomer about it too hard. As we don't have a clip of it blowing yet. I believe we might have some of it, but we'll
let the stream roll for now. If they terminate the stream, we can probably go back and look at some footage before we close quickly, but we don't have any footage that we've gathered ourselves.
Yeah, exactly. Well, good God.
Yeah, I reckon it's gone.
Yeah, oh yeah, no, that thing's gone. I was expecting to lose it on landing, but yeah, no, that thing will...
Oh, well, comment the booster seemed to touch down a little bit hard, didn't it? I thought it felt a bit rough. The booster seemed to hit the chopsticks a bit hard.
Really? I mean, it seemed normal to me. Honestly, that booster catch seemed much closer.
I'll go back and take a look. Maybe I'm just
Yeah. I mean, it seemed fine.
Oh, it did well.
Okay, everyone on Twitter is doing. This is fucking hell.
It's all
Okay.
going wrong.
I'm gonna have to log off Twitter. That's...
Well, you've lost nothing by logging off Twitter anyway.
Yeah, it really does. Okay.
You've only gained time, and you've lost access instead of gateway
Oh my
Twitter,
God.
which you should all follow anyway, I suppose.
Yes. We will have something later. Well, that sucks. I was expecting to stream longer, but you know.
Yeah, booster was cool. That's pretty cool.
Progress is never easy.
Yeah, that's true. Hey, good reason. They don't target orbit arbitrarily for no reason at all. Quote from Ken Kirtland here. Very much agree. Yeah, rip. Failure
Any speculation in your heart, Perigee? You want to get your speculating hats on?
Oh, you wanted me to get my speculation hat on?
Go on. Let's get speculating. I don't think it was a ULA sniper this time.
Sure. My guess, my honest guess is that tank ice interfered too much with the new downcomers for the RVACs. It might have chipped it a bit more than the regular downcomer. Might have sliced it open, leading to loss of engine, then eventually loss of vehicle. I estimate this will probably be like IFT2, in which they will solve this fairly quickly, and then move on to the third flight. I mean, the next flight of the vehicle. Yeah, that's about it. I don't think this is like death blow, like, or anything. This is not, obviously it's not good, but it's not like terrible. Yeah, that's my
Starship
guess.
program finished.
It's
True.
over. SpaceX is done.
So, would it be safe to assume that Flight 8 will be a repeat of this flight's itinerary? or will
Very
we
much.
see the?
Very
Well,
much.
Yeah.
I mean,
Yeah.
maybe I can see them testing some more hardware on the booster, probably recovering some more engines, maybe testing. We did notice an engine went out on launch. I wonder if that's the recovered engine. I bet it is.
It
But
might
I'm
be.
sure they'll refly more next time to test.
Yeah. It might be. It might be. God, this is.
That was a beautiful landing, though.
Yeah,
It
no, that
was
landing was
lovely to see.
picturesque. That was perfect.
As our producers will be very happy to announce, we got it on video really nicely. It's
Oh.
really a nice shot.
Huh.
I mean, you can see it hanging there, so they've done a
Yeah,
lot.
the booster's hanging beautifully there. Wow. Wow. Victory for the booster teams. Loss for the ship teams. The ship's new on this one, so I don't really feel particularly strongly about its loss. This sucks, obviously, but Ship 34 is already in cryo. Good chance that maybe this just delays the next flight till, like, late February. I would guess. Longest part on this is probably going to be the mishap, but because it's suborbital and the license has already been lessened in scope, it's probably not going to be that bad. I don't know. This sucks on the ship side, because this was meant to certify it for orbit, so orbit's been pushed back to Flight 9, which means that Ship 35 is gonna have to go to orbit, or either that or they'll push it on the next one, and I doubt they'll push it on the next one. On booster speculation side, my guess is that they will be we'll either see a re-static fire of B-15 or either a reflight, a refire, or just a whole bunch of static tests on the thing. So, I mean, the booster looks in way better condition than it did on 12. So, that sucks. Some programs that are gonna suck on this, but I mean, yeah, I see people speculating that it's for the same reason that 2 failed. So, yeah.
Just got a question from Mary Herf here on the Twitter. Did Starship blow up after separation? Yes, we think it blew up. What we observed was after separation, approaching the Starship cutoff of the engines, a bunch of engines went out too early on one side and kind of moved over to another side, leaving one RVAC engine on, and then telemetry was lost. What exactly happened, we obviously don't know. The investigation will be very interesting, and we'll keep an eye out for video. And let's listen to what they have to say.
There is footage of Flight 7 breaking up over Turks and Caicos. I believe we will have that queued up for you in a second. The thing looks beautiful in depth, I'll give it that.
Also, beautiful views of the booster, courtesy of Interstellar Gateway.
Alright, well, as the SpaceX stream closes out, don't go anywhere. We're sticking around for a little bit, just to keep speculating.
Very
Thank
much
you for
so.
sticking around to the stream, though. Your support is much appreciated. Lovely cam of the booster as well. The engine seems to have held up well. I'm interested in how 314 is done. got a really nice video that we'll hope to bring up in just a second.
I'm sure we'll hear something for about 314.
Quite a tragic loss, though, if it's, like, exploded itself. Question here from Sanjay Jairam, who asks, if it broke up over a populated region, does that mean a mishap investigation has to happen? Perigi, I imagine you're more into the FAA than I am, given I'm a Brit.
A mishap would have to happen no matter what, because it broke up in early into flight. So early into flight just means mishap no matter what. It's permitted to break up during re-entry. However, this is very much not re-entry. So I would expect it to, yeah, full mishap.
Right. Well, good news, we've got a really sweet video of what we presume is a ship re-entering, which we'll queue up for you now.
Yeah, let's take a view of this beautiful thing.
This video is posted by Alex Deeds, A Davenport 354 on Twitter, so it's not ours, but it does look pretty amazing.
We have another view of the aft flap on fire. We will show that in a second also. Not from us, spotted originally by at TJ from Funland on Twitter.
Does line up pretty closely with what Joey Leal was saying about two bright dots. It's
Yep,
incredibly
exactly.
pretty and also incredibly damning. So something seriously went wrong, and that's going to be an interesting investigation.
Yeah.
I wonder what the brightest parts are there. Clearly, in the middle of the debris, you could see that there's like really, really bright material, something that's burning really brightly, and obviously it's maybe a part still together, or just something more...
Yeah, probably. Wow, that is pretty. Okay. Well, yeah, this sucks. But
At least the loss is still awesome.
yeah, exactly. Again,
The loss looks badass.
yeah, the loss looks great, man. In
Excitement
addition to
guaranteed.
the loss looking great, like, man, a booster reflew in its entirety. Ah, there we go.
We've got we've got a video coming up for you now showing
there you
some
go.
flames in a flap hinge, which we think is pretty important.
Yeah, probably.
That was absolutely insane.
Meanwhile,
This is caught by TJ from Funland on Twitter.
Yes. Anyway, yeah, as we know, give him 2 weeks. S-34 is already out on the cryo stand. You know, yeah.
Like, I mean, you've got a brand new flap design, brand new hinge design, brand new flange design, brand new, probably motors, brand new fuel lines. Something's bound to go wrong.
Yeah. They also, in addition to just everything being brand new, if you really loved the reliability of the of the Block 1 ships, please take time to heed your elders and remember you had a whole SN program to go through. This is a very different design. It's a much lighter design, much better design, much leaner design. They'll figure out what they need to add back, and it'll get added back. It's a theme. Welcome to the Starship program. Explosions are nothing new here.
Remember when I used to be a tank watching kid in my youthful days, like golden days, and we'd wait to watch the little tanks pop as they pressure tested them. And that was the most exciting thing that had happened that whole week for me. At least now the explosions are bigger. Talk as if I'm not 18, and I'm like some kind of elder looking back at the glory days.
Look, to be fair, you're older than 90% of space Twitter. It's all right.
Maybe I am a grandfather. What a nice shot of that booster, by the way.
Yeah, no. I wonder if there will be a way to obtain, perhaps. Oh wow! Oh boy! Okay.
Look at that, the
All
streaming
right.
gods that be have answered
Emlyn,
our prayers.
I'm just gonna ask. Yeah. Oh, yep. Nope. Okay. There we go. Wow.
Ooh.
Wow. Okay. If there's any way you could get like a still frame of that, like a picture of that,
That's a new
poster.
phone wallpaper, I fear.
It's gonna be my new desktop background.
Yeah.
Thinking back, this is a bit funny, but thinking back to our discussion before the launch, we were talking about a rather dynamic re-entry, and that is in fact.
The time is 23:09 UTC. I can now confirm this re-entry was dynamic.
There we go. Yeah. Good God.
This may even have been off nominal.
Perhaps, perchance.
It's very possible they didn't check their staging.
Very possible. Extremely possible.
I think this launch is going to get memed an awful lot.
Oh yeah, definitely, definitely.
You know, a part of my heart feels sorry for those little Starlink mass simulators. They're like a flock of children.
No, they're just spiraling.
Like imagine they're so excited to go on a little trip and to end up with a swim in the ocean, and instead they've been plunged into the atmosphere alongside the burning wreckage of their transport vehicle. I mean, that's terrible. That's terrible. I wouldn't wish that on anyone.
Yep. Oh man, R.I.P. 33. It's fine.
Going back to that re-entry video, I have a bit of speculation. Perhaps it could be. No, that wouldn't work. Never mind.
No.
So obviously, to deploy the mass simulators, they've got to be arranged in some kind of rig that shoots them out. So maybe that held together, and that's what the big mass was. Because I can't really think of anything that wouldn't disintegrate upon that happening.
Wait, Jacob, you aren't supposed to do actually good speculation.
I
Damn.
think it blew up because it was too heavy.
This is true. This is true. This is true. They got him.
That actually will be interesting to look back at in a bit more detail.
Too heavy. Did they take the double welds off of the booster or off of the ship?
Off of the ship, but I doubt that's related.
Yeah.
No, it's too heavy, so we need to take just off the sides of the ship. We just gotta get rid of the sides.
Just based on the
true.
engine failing, though. Those engine failures reminded me an awful lot of which flight was it where we had engines failing in like a pattern due to an issue with the fuel line? Which one was it? It's one of the early ones, I remember.
Everybody's acting like this is the end of the world. Oh my God.
It is. SpaceX is doomed.
Yeah, no, it's the end of the world. Literally everything is over. Oh my God.
Oh,
Did
the Thunderfoot video is going to be great.
Did they tell you they had 10 Starlinks on it? They actually had 10 thermonuclear warheads. They are all raining down.
SpaceX is doomed.
They're coming for the Turks and Caicos, dude. It's over.
Turks and Caicos. I think everyone's ever woken up and thought, you know what? Fuck the Turks and Caicos.
Yeah, fucking man, dude. Starship thermonuclear warhead. Alright, I think we might be getting a little too silly with it, but frankly, the ship exploded, so I think the
it's very little we can do.
We're raising morale. We're raising morale.
Another video
Yeah.
in a moment.
If Emlyn, Mr. Joey, if anyone feels too unprofessional, please feel free to yell at us, and we'll make like the SpaceX.
Parody, that's not necessary, because I've just been informed by Sanjay Jayaram in a YouTube chat that they actually had 23 septillion copper needles.
Oh my God. Jacob.
Oh,
As the
I was
creator.
not expecting that.
Wow! 23 septillion copper needles!
Oh my god.
Wow.
What a legacy.
Wow.
You
Oh
know,
my
that's
god.
the legacy I want to have.
Generational, Jacob.
I understand not everyone watching this understands that joke. I'm very sorry if you don't and we seem deranged. We aren't normally like this.
Yeah, we were very professional and then the ship exploded, so...
Oh, very is a stretch. We were.
And
Very
with it
good.
exploded any semblance of professionalism, so forgive us.
Yeah, I think this is it. No, everyone is doomerang. God,
Except for us.
Christ.
After party.
Just chill.
The after
Chill,
party.
fellas.
Never describe this voice chat as the after party ever again.
Oh no.
The before party.
I wouldn't open Joe Barnard's X account right now because he just posted a photoshopped image of New Glenn on top of the Super Heavy booster, and it makes me rather uncomfortable.
I just scrolled on it as you said that. Wow.
It's terrible. I repeat, do not visit his page. Worst mistake of my life. Those of you just joining
Is
us
this real?
now, I apologize for the lack of intelligence. Unfortunately, the ship was lost. A catastrophic failure, a very dynamic re-entry. The booster is completely fine. The only off-nominal thing that happened to the booster was an engine failure, which I'm guessing is probably the reflown engine. But aside from that, everything went great. Great catch, it's in great condition, it's venting, everything's fine. The ship, however, ended up in a fiery re-entry over the Turks and Caicos, which is unfortunate and will require quite a lengthy mishap investigation.
Oh my god. Dude, people are going insane over this.
There are people whose entire lives are the SpaceX program. Are you surprised?
What? Man.
There's a couple new perspectives on X.
Go on.
Should I?
Hit us with the speculation.
New
and
perspectives
source,
of the debris.
Oh, you mean
Oh,
videos?
someone says, "Are these drones?"
These are not drones. Nor are they UFOs. That being said, I think a lot of uninformed people in the Turks and Caicos may be praying right now. Because I think I would be too if I saw angels of fire and death ascend from the heavens above my home.
Yeah. Oh my god. It's not that serious.
Those tile hunters are probably gonna have a field day.
Oh yeah.
Oh
no.
yeah.
1,500 tickets to Turks and Caicos, please.
There we go. Oh wow.
To the viewers in the chat, do take a look at eBay in a couple of weeks' time and just search Starship Tile.
So, Emlyn, if you want to put
Someone's
up
going
some
to
of
be
those
selling an
videos
actual
that
mass
posted on
simulator.
my IGW account, man, we have some phenomenal viewing of this booster that got caught. Oh my god! Wow.
Holy cow.
Oh my god. Please chill.
Does anyone know where the Pi booster was placed on the bottom of Super Heavy?
I've heard, okay, so I've heard two pieces of speculation. One piece is that it was regular, and the, like, Raptor boost, and the other one I've heard is that it was converted into a Raptor center. Yeah. So I don't know where it was. My genuine guess is that it was the one that was out, and then the one that was relit. So, honestly, okay, going back into some actual helpful speculation, I think that that shows that SpaceX is, like, their biggest enemy of all of this is the Raptor startup cycle. On Flight 1, it was 100% startup cycle that just beat them over the head with so many engines out.
Yep.
Flight 2, they conducted so many tests of the startup sequence and the spin-up ports, and we saw how much better Flight 2 went. And then they did that same thing with Flight 3. They dropped it a bit on Flight 4. There's an engine out. Then Flight 5 perfect, Flight 6 perfect, and then now Flight 7 perfect again, except that one that didn't relight immediately, and then somehow relit again. So that means that probably the startup was judged to be unhealthy the first time, and the startup was judged to be healthy the second time. Really interesting that they can go without, right? Like, they can go without an engine for boost back until we find. And that's great. We saw that happen. So that's so much redundancy in the future.
Yeah, just saying again, if you haven't already, please do take a look at the X account of us, of course, Interstellar Gateway, because there are some phenomenal images on there.
Yeah. Wow. Man. So we're gonna so after this we're gonna see them lower the booster. Oh, yeah, no. Likely that planes are being told to divert away from where the debris might be. Well, no.
Let's see if we can take a look at NOTAMs around that area.
Yeah, no, it's probably due to the NOTAMs themselves. Yeah. So, nah.
The NOTAMs take this into account, right? They can't just
Yeah, they
say, "Oh, they're gonna
Yeah.
fly perfectly," and
Yeah, no, of course the NOTAMs take this into account. God, yes. Ugh.
Okay, there is a, this was pointed out, Marcus House has retweeted a video on X from, I believe it's Flyer XT Pablo, which actually shows the explosion. So we're going to see if we can get that up for you shortly.
then we could speculate more.
Yeah, this video is absolute gold. You're going to love this. Or hate it, depending on how bad you feel about it exploding.
Yeah.
Daniel says they're lowering the booster already.
Oh, wow.
Let's take a look.
Oh, excellent.
It does appear to be a bit low, doesn't it? Would you look at that? It's going down. That is really
Yeah.
quick.
There it goes.
Brilliant.
Someone post that.
Oh, venting.
Booster's venting. It's over. It's not actually over.
Awesome.
It's never been so vent.
Oh, wow. That's moving quick, actually.
It is actually
Shit.
pretty fast, yeah.
Yeah.
This
There
is
we
faster
go.
than last time, yeah?
Yep. Coming back there.
Ooh, that flame. That's cool.
Yeah. Did that on, what was it?
So on descent, when like the booster's landing, I saw this on flight 6? Flight 5. When it does that big like woof up the side, that's because it's venting all the excess stuff in it at that same time, or what's the cause of that? Do you guys know what I'm talking about?
Yeah, I think.
Yeah, vaguely
Okay.
remember it, I'm afraid. Twas many moons ago.
Yeah.
Well, I saw it happen on this one too, so not to the same extent nearly.
Mm-hmm. Yep.
Hopefully shortly we can bring up that video, but for now, take a good look at that booster. And
Yeah,
this flame
get
from the
lowered
quick
down.
disconnect.
Yes. We are about to see a RUD. Now we're chilling. We're
Okay,
chilling.
it's alright.
Yeah.
No, I mean, it'd be pretty impressive if it blew up now. I'd give them kudos for that.
Yeah. I don't know how, I don't know how I would do that, but
No, this
Yeah.
looks completely normal. This looks fine.
yeah. There we go. Yep. Oh, wow. Wow, I mean, they're just venting everything else out, but they're pushing it over. I think that's much quicker than they did the first time that was over the OLM. Yeah.
Bigger flames, it looks like now. Slightly bigger. Bit there.
It's a pretty shot, though. It's a good thing we've got these cameras.
Yeah, no. Oh, wow. Yeah, no, this is going to make such a good shot. Someone get some photos of this. Breathing
The
fire.
flame is getting bigger, good lord. Comment from Naval Mates in YouTube saying me after the laxatives. It's terrible.
Maple.
God. Chill, chill.
It's terrible. Why would you say this?
Why? Why?
Alright, in just a moment now, we're going to have a video to take our mind off of laxatives, though, which actually shows, it's unconfirmed, but seems to show the explosion of the ship, which is a big deal. In just a moment.
Mm.
Good lord.
Yep. Wow. Wow.
A video from Flyer XT, from the icon of the sea in the Caribbean Sea.
Well, that sucks. Launch failure.
That is a really amazing video, though.
Yep. I think we're about to see, for chance, the worst occasions on Twitter.com since Flight 1.
Spaceflight community will be in shambles because of this.
Yes. Starship over. SpaceX over. Alright.
Well, you know, I'm not fond of name dropping, but the fun of it video is going to be fantastic. That's all I'll say.
Yes. Yes, agreed. And then suddenly it'll all go back to normal in 2 months.
The next Starship will launch and we'll forget this ever happened.
Yep. Exactly. 'Cause
So,
that's the way it works.
was ship above the line when it blew up? Yeah,
The
that
line?
makes sense,
What do
right?
you mean?
The Kármán line. Like, was it in
Mhm.
space?
Yep.
Yeah.
Hmm.
It's quite, I mean, this is much more dramatic than IFT2, though, isn't it?
Not really. Flight 2 did the same thing.
IFT2 did that overnight, didn't it?
Oh, yeah, it did do
Like,
it.
for it to be visible during day that brightly, that's a big, big flame.
No, hold on. I'm looking this up. Let me see.
Probably safe to assume that's the biggest in-space explosion since,
Yeah.
like the nuclear tests back in the 60s.
Oh, yeah, probably.
Like Norman says, this could finally be a use for Elon's flamethrower. Rapid flaming detank for it to boost the quick
Incredible.
disconnect.
Yeah.
Looks like it's
Wow.
venting concluding now. And that booster is presumably now safed.
Yeah.
Brilliant. So that's a booster fully recovered, and it's doing well.
Man, just the like sunlight hitting off that booster. That's just a beautiful, beautiful shot.
Mm-hmm.
It's wonderful.
Yeah. So.
Well, we're approaching T plus 50. If you're joining us now, unfortunately, the ship is no longer with us. The booster's doing just fine. It's recovered and everything is well with it. The ship exploded at, we presume, 146 kilometers before there were some engine failures, and then it went boom, and that's been caught on video by quite a lot of people.
Mm-hmm.
Just take a
Yeah,
look
if you're
at
just
extra
joining us now,
cool.
you're about 37 minutes late.
A little bit, but, you know. Maybe you got your time zones mixed up. I don't judge. I've done it before.
Yep.
I reckon we'll give it another 5 minutes, see if anything massive, consequential happens, and we'll see from there.
Wow. Yeah, no, super heavy. Super heavy did it again.
They did it again. It's reassuring that none of the that there have been really no big issues with booster itself and catching. The only real issue we had was with the ground equipment. It seems to already be a pretty reliable system.
Oh wait, hold on. Oh shoot, I forgot. I can post the Starship Jack.
The what?
Starship Jack.
Starship Jack?
Sent it in the channel.
Oh, that's terrible. I think. You know what, Mr. Emlyn, I fear we may have to get this on stream.
No, we do not need to get this on stream. This is 100% not something that needs to be on stream. All right.
Oh, it's terrible. It's terrible.
Okay. Are we expecting any bigger movements?
Nope, nothing big. I think we'll give it a few more minutes, see if any other videos drop, and then we'll leave it there.
Mm-hmm.
I just had an observation actually from Emlyn, who's commenting on flight paths of lots of planes diverting.
Yep.
Maybe if we could bring up flight radar or ADS-B exchange.
Yes, there you go. Yeah, you might want to bring that up.
Unfortunately, SpaceX is going to make a lot of holiday travelers very angry today.
100%. That's not good. Yeah.
I'm just pulling up a feed for you now.
There we go. That's not good.
It's the booster gently kind of spitting out a few flames. Surprised it's still got some stuff left in it, to be honest.
Yeah, agreed.
I think it's really hard to conceptualize just how much fuel these things actually store. Like,
Really funny seeing all the... Oh, sorry.
No, it's fine. I was going to make a stupid comment. Go ahead.
I was going to make an equally stupid one. It's really funny seeing all the planes around there going around in circles. Click on any one of them in flight radar, they're just doing donuts.
We're standing by for a sec to get an interesting view on the ADS-B exchange.
This is... Wow.
This is definitely more dramatic than IFT2.
Yes.
Wow.
IFT2 definitely went out with a whimper compared to this.
Yes.
Just being honest, feed cut, and then it was like, yup, see ya. Now this is actually like This is something we can follow.
There we go. I've got an ADSB exchange view now.
Yep.
Oh, yep. Oh no.
Wonder how it feels to be on one of those planes right now.
Oh no. I wonder how it feels to be an air traffic controller right now. You just have to.
Oh no, yeah, the
so
poor
much- Have to
ATCs.
cut so much airspace. You're gonna have to put so many people into holding patterns. You're probably
no.
gonna overwhelm some poor little like diversion airport with 5 billion aircrafts all trying to stack in on approach. Oh my goodness. Oh lord.
Wow, my first day as an air traffic controller.
How bad can it be? And then angels descend from the heaven carrying fire and flames.
Attention all passengers. Space debris is rapidly closing in on us at 2 kilometers per
Oh, that's a
second.
good point. I hadn't thought about the in-flight announcements. Ladies and gentlemen, from the cockpit, this is your captain speaking. If you look out to your left, that is why we're not landing.
Really? Oh god, okay.
I guess if we kept the stream running then, jeez.
Oh wow.
Just
Sun
think
setting
about
on the
how much
booster.
compensation will be claimed. Oh, it hurts.
Do you think they'd charge SpaceX?
Oh yeah, no, SpaceX, if they're any fine, SpaceX is gonna have to pay.
Oh. It might be slightly more over than previously thought.
Yeah,
This
that
is,
part sucks.
I worry
Yeah,
about them having maybe to do an environmental assessment for this too. This is actually quite big.
I doubt it'll be an environmental assessment. The problem
hope
is just
not.
going to be, yeah, negligence.
Yeah, because most of it's just going to be metal. It looks like, you know, a lot of the methane and oxygen kind of did their thing in space. And I doubt, like, residual amounts might have actually made it.
Yeah,
Metal,
probably.
the fish can have a bit of metal as a treat.
Actually,
Yeah,
it's funny you say
exactly.
this. Actually, wreckages are really good for aquatic environments because they provide perfect beds for coral.
Exactly. So
So if
SpaceX
you-
did a good thing here.
Exactly. No, seriously, if you take a look at like plane crash sites, they're often filled with new coral reefs because they just provide such a perfect like artificial hub.
Point Nemo is probably... Actually, that's probably too far down.
So, just reading back on the chat, RC Freunde Owl made a comment. Something else I noticed as well. There's a little bit of floppy on the left side of the ship during launch. Did you guys notice that? Like a little bit that was flopping about in the wind.
Yeah, that guy was wiggling a bit. That was... There was like a tile.
It was like a.
I don't know if it was a heat tile. It might have been like... Ablative is put on in sheets, right? It looked like it might have been ablative, just kind of wiggling a
I
bit.
think it may well have been. It was just kind of wiggling about.
That's what caused all of this.
Yep. Not actually. Don't
Yeah.
spread misinformation on Twitter now.
This is not... This was a joke. This is not misinformation.
Please don't sue us. We'll do anything.
Yup. The
Well, I
ablative
mean-
sheeting did not destroy the Starship.
Oh well.
The ULA
most
sniper
likely
did.
Did not. Yeah, true. There you go. ULA sniper's got improved aim now, given that he shot it at 146 clicks above the surface. That's pretty impressive.
Tory
I
Bruno
can-
himself smote it
I
from
can
the
shoot
heavens.
reliably with iron sights out to like 70, 80 yards, but 146 kilometers. Wow.
Yeah, it's fine.
I go on one of my usual Twitter prowls and see if I find any other interesting videos there.
Good God. People are freaking out for no reason. Okay. Alrighty. Well, Oh. All right. Well,
I reckon we call it here. The Perigee.
yes, ladies and gentlemen, yeah, thank you so much for coming in to view the Interstellar Gateway, uh, flight, flight 7, flight 7 stream. Thank you guys so much for joining, for donating, for everything. Thank you for being here. It was incredible. The ship exploded. It's a great day.
Exploded.
Yeah, sploddy. All right.
Yeah, so
Thank
if
you
you're looking
very
for stuff
much.
to keep an eye on after this stream, definitely keep an eye on the official SpaceX Twitter. Keep
Yes.
an eye on ours as well. On
Yes.
Twitter, sorry, x.com.
Yeah.
Keep an eye
Incredible.
on ours as well. We've got a bunch of
That
really cool
Interstellar
videos
Gateway.
coming. Yeah,
Yeah,
there you go.
thank
That you will not want to miss. And hopefully SpaceX gives us some other insights as to what actually happened.
Yep. Exactly. All right. Thank you.
Thank you for being here,
Bye-bye.
guys. Take care. I'll see you next time. Hopefully.
All right.